my brother works twice. Alrighty. It is Tuesday, right? It is Tuesday.
Unfortunately.
Okay. We made it another week. I did survive last week. It was rough. Went home and threw up. So that was when your sugar gets to like 400 or 500. It's bad. It's bad. So no, well, usual colors, not like funny colors. No, no, that doesn't usually happen. I just get real awful. So I know now that was bad. Let's see, a little high right now. It's fun. It's like a balancing act. Too low and I'll pass out. So it's always fun. But this is fun technology in my pocket, thanks to developers who wrote this. So it's pretty cool. All right, so we have a couple things. So the group tutor sessions, there is not one for Thursday. Mr. Tim is out of town, unfortunately. So hopefully you can make that next week if Thursday's your day. And then we do have all sorts of other tutors scheduled through the Academic Support Center. I can remember the page for that. I think it's just ASC. Nope. Can I not spell it all? Am I not online? That's weird. That is our website, right? W's? Okay. Well, that's different. Okay. It's out there. Maybe the syllabus link will work. We'll try that. Or nothing will work. Okay. Let's see. Let's try one more time. I really want to find this here. Make sure it works. Tutoring. All right, this page works. Sure. So the two different schedules now, because things are stupid, which should be changing by the end or the start of summer, maybe, I've been told. So Auburn Hills hired a... Okay, those pages don't work. Auburn Hills hired a tutor. So there's one CIS tutor out at Auburn Hills. You can contact Auburn Hills to schedule with that tutor. Or Orchard Ridge has a bunch. Contact Orchard Ridge to schedule with the other of them. Oh. Okay, it's going to be one of those days. So that's fine. But yeah, do take advantage of that. If you do the group tutoring or individual tutoring, let me know. I'm happy to throw a bonus point at you for quizzes or labs, once per week, for going to any one of those. So Mr. Tim sends me attendance lists. If I tell him who's in my class, I should really go do that before I forget. The individual tutors, can you have them email me and say you met? Because getting records out of the ASC is like pulling teeth. And it's much easier if they just shoot me an email. It'll make everyone happier. If it's easier for me to do, then I'm much more likely to do it. So just have them shoot me a note if you do. And then hopefully that works with your schedule somewhere. We've got varied hours across all the different tutors. So, I don't know why the page doesn't load. That's real sad. But that's okay. All right, so wanted to start with, this is where I was. Was this loading? Yeah, so let's talk about the lab. Had a couple questions. I think it went pretty well for most folks. For lab one, our first intro to getting some user input and dealing with user input. So our programs are much more interesting this time around, where when it runs, I can give it different numbers and I get different results each time. From here on out, that's what we're going to do. Every time we run it, we can give it different numbers or different inputs and get different things to spit back out. If every time we run it, it does the exact same thing, it's really boring and no one has any fun, and it's not very useful. So, they're doing maintenance on the OCC website today. Okay, that's sure. Not usually how websites work, but okay. All right, so let me start up. So I'm going to do this in the class repository, though, because if I do it in the private repository that was created for Lab 1, you won't be able to see it. So just that one step will be ever so slightly different, but that's okay. So it's in my 1500 folder here, and let's call this Lab 1, not 21, Lab 1, and make a project. We'll see how long my voice lasts today. All right, so we get our starter code. I always like to run. If you don't get the run button, you can do the little hammer to build first, and then it should generate your run button. There it goes. Now we get a run, and we should get hello world. Just make sure everything's up and running. I had a couple people get errors off this very first step, which is confusing. Should work. So if it doesn't, let me know. We can hop on a screen share. Usually something to do with this configuration. You can pull in the drop down and edit your configuration and do all sorts of interesting Java stuff here that mostly it's just magic that happens, but you can pick which version of Java you want. And usually the latest is fine. If you're using 18, it doesn't really matter too much. And then what class is running. Remember, the name of your class matches the name of your Java file. That's a hard and fast rule in Java. So if you happen to rename things or copy paste things from different examples and the names don't match, it's going to be upset with you. So, but usually easy enough to fix, and it kind of tells you if you have something else. Like we try and call this lab 1, you get a nice red line, and you hover over the red lines, and they tell you what they're upset about. So it says lab 1 is public, should be declared in the file name lab1.java. This one's helpful. Sometimes the red lines aren't all that helpful. So you could rename the file, or you could just put this back to match the name of the file. Either way works. Right. So if we're dealing with user input and asking the user to type stuff in, which we're going to do from here on out, we'll just get used to copy pasting this line. It's scanner, call it anything you want. I like the word keyboard for it. It doesn't have to be keyboard. It could be scanner. It could be input. It can Apple. This is just a variable name. As long as it starts with a letter, Java's okay. Equals a new scanner given system.in. And then the first time we try this, it's going to give us some red lines and say it can't resolve symbol scanner. It doesn't know what a scanner is because it's part of the Java library, but we have to ask for it. If Java loaded everything in its library, it would run kind of slow. So it only loads the stuff it needs. So we go ask for it. So you can import class here, and it adds your import line. You're welcome to copy paste it in yourself or type it in yourself if you like. Again, I'm kind of lazy, so I would rather let the tool do that stuff. Then the red line should go away. Once we've got this, then I can start asking the user to enter values. You can get numeric values directly. I don't recommend you do it because it will cause problems later. So every time we're going to get numeric input, we're going to convert from characters to numerics. Whether or not we need an integer as a whole number or we need to double some number with a decimal place, that's up to us. So we should tell the user what we want. So again, system out print line, or if you like shortcuts, it's SOUT for system out. Tab will fill in the rest for you. And then we can, inside those parentheses, put some quotes in here because we're putting in a string. This is a string literal, just a bunch of characters here. We'll ask them to enter something. So we say, enter the number of credits you have so far. And then we need a place to store it. So we're going to tell Java, hey, I need a place to store these. So, this is probably a whole number. You don't often earn half a credit, best I can recall. So sure, and if you want to make it a double, it's not going to hurt anything. You can store whole numbers in doubles. That works too. Either way is fine. And this is our number of credits completed. Again, I'm fond of really long variable names that tell you exactly what it stores. If you just call this credits, you probably know what it means, right? And you'll probably be fine, and you can figure it out. But when you come back to some of your formulas later, you'll have like credits minus other credits, and it'll be kind of confusing. So, usually it's better to be more descriptive. It doesn't hurt anything, and you don't have to type the whole thing anyway. You type a couple letters and hit tab. It's not like you've got to type it all. So we're going to tell Java, hey, I need a place to store this somewhere in memory. I don't care where it is, just save me a spot somewhere. Java says, okay, and where do you want to put? What do you want to put in it? So this equal sign is our assignment operator. We're going to assign a value there. Well, what we want is the keyboard next line. Give me the thing the user typed. Keyboard next line is whatever they type in and hit enter, we're going to give you back. But now we get a red line that says, hey, required type is an int, provided string. Oh, well, keyboard next line gives you a string, gives you a bunch of text, a bunch of characters. It's not an integer, so we have to do that conversion. So it actually suggests it here. If you take the suggestion, you can wrap it with integer.parseInt, and then in those parentheses, you give it the keyboard next line. Right? Take whatever we get from the keyboard. Right? We still follow order operations, so parentheses go first. So this is inside the parentheses. This runs first, gives you some input. Whatever the user typed and hit enter, great. Now we hand that off to integer parseInt, and hopefully it turns into an integer. If you typed in something that's not a number, it's going to crash. That's on you. So sad. Later we'll figure out how to fix that and be a little bit nicer and not crash our programs, because everyone hates when their programs crash, but we're not there yet. It's okay. Cool. So now I have an integer value for number of credits completed. And we'll essentially do this again. So I'm a little lazy. I'm just going to grab both these lines here, copy and paste. Oops, not cut. And change it here. How many number of credits you need to graduate. And this is number of credits needed. Right? Different prompt, different variable. Another place to store it. So now I have two numbers stored somewhere in my computer's memory. I don't care where. When I want the value, I tell Java, give me the value by name. Okay? This is my way of referencing it. Okay, and then we do it again for how many credits you take on average. So enter the number of credits you take per semester. Semester. Nope, that's not spelled right. Come on. Semester. There we go. Okay. Now this one could be a double, right? You might tell them, hey, I take 6.5 because that's accurate. You might expect someone to say 6. Either way is okay, but remember, if later on the arithmetic we need to do, when you take the number of credits you have left divided by how many you take per semester, if you want to have a decimal remainder, one of those numbers needs to be a double or something with a decimal. If you take an integer and divide by an integer, Java says, oh, you must want an integer back. And you say, no, I wanted the real answer, but Java's like, no, you get a whole number back, which is really frustrating. So one of those numbers needs to be a double. So might as well make it this one because it might be a double. So instead of integer parse it, it's double dot parse double. Right? And this will be our credits per semester. Right? Change the variable name. So now I have 3 different things stored in memory. Right? We're just saving these somewhere. The last thing we need to ask for is how much does it cost per credit? Again, might be a double, might be an integer. I don't actually recall. I don't think we charge pennies. Is that worth Googling? The website wasn't working anyway. So, I have double here, so I'm just going to leave it as double because why not? So this is enter the cost per credit hour. And this will be cost per credit hour. And double parse double, sure. If you give me some pennies, you give me pennies. If you give me a whole numbers fit inside of doubles, right? A decimal place can be 0, and it's still a whole number, right? So that's fine. So we've got all the information we need here now from the user. They've typed in 4 things. Now we can start doing our arithmetic. A couple options. Either way is perfectly fine. The number of credits you have left, we're going to use twice, right? We're going to take that divided by number of credits you take per semester. We're going to multiply that by the cost per credit hour. If you're going to use it twice, you might as well make a variable for it, right? Otherwise, you have to type the same arithmetic twice or copy paste it twice. And there's a general rule of thumb. If you have the same code more than once, you should feel bad about yourself because you can do better. That's sort of joking, only sort of. We can do better. So, I'm going to make another variable. So we'll have a integer for credits remaining. So tell Java, hey, give me another place to store a number. It's going to be a whole number, and that'll be my credits needed, number of credits needed, minus my number of credits completed. Right? That's how many credits I have remaining. Just the simple arithmetic. Then I'm going to get how many semesters I have left, right? Which we're going to round up. So you might think, hey, this could be an integer for number of semesters left. Right? We said to round. Remember, we talked briefly about it. There's this math library. Type math dot. You can do all sorts of cool math things. And I said, hey, the math seal is good at rounding things up. It rounds to the ceiling. Right? So if it's not 4.0 or 3.0 or 2.0, it'll round up. Right? But 2.0 will stay at 2.0 because 2 is already a whole number. So that's fine. Excuse me. I'll say, okay, so what do I want to round? Well, I want to take my credits remaining divided by my credits per semester. Sure. This is a double. This is an integer. One of the two, right? We'll make sure I get a double result that can be rounded. If both of these are integers, bad stuff is going to happen. But now you look at it and you get another red line. It says, required type int provided double. Not the most helpful thing here, but it's telling us that seal is giving you back a double. It takes a little bit of reading to figure that out. It's okay. So I can't say this is an integer because it's not. So math seal is going to give me a double, just like double dot parse double gives me a double. So easy thing is just call this a double. It's not going to have any decimal. It's going to be 0.0 because I've rounded, but Java says it has to be a double. So we say, okay, sure, it'll be a double. It's perfectly fine. There's other ways to do this, and you can turn them back into integers and do all sorts of other things. Anyway, any approach is fine. Not too big of a deal here. All right, so that's my semesters left, and then I have the probably a double again, because if my cost is a double and I multiply, I'm going to get a double result. So this is my cost remaining, or remaining cost, or I don't know, sure, remaining cost. I think that sounds okay. Is my credits remaining times my cost per credit hour. So now I have a bunch of numbers all stored in memory on my computer somewhere. It's barely any memory. I don't care. You can store hundreds of these integers and doubles, and your computer won't care. Right? We're pretty spoiled. We've got gigabytes of memory. Right? A kilobyte is 1,000 bytes. A megabyte is 1,000 kilobytes, or 1,000,000 bytes, and a gigabyte is 1,000,000,000 bytes. So like, it doesn't matter that we're using 4 plus 4 plus 8 plus 8 plus 4 plus 8 plus 8. Like, no one cares. It's okay. Later on, you can care about doing things efficiently. We just want to solve the problem, and it's okay. Right, now that I have all this, I can start doing some more output. Couple options for output. Right, you can do the really cool formatted stuff. We skipped over some of that. I said go read it. It's interesting stuff, but it's fine. Like, it's not that important. The slower way to do it, and it's okay, there's nothing wrong with that, is we'll say you have, and then we're going to append or concatenate. Right, you can take a string and stick something to it. You're not adding, but you're going to take one string and add something to that string and get a bigger string. Right, just stick a value on the end here. So this will be my number of semesters left, and then we'll append, concatenate another string, semesters left. Right, and we'll do it again for your estimated cost is, and then maybe a dollar sign if you want. Again, I don't really care too much about pretty at this point. It's it's nice, but not the end of the world if it's not pretty. Here, the estimated cost is plus the remaining cost. We'll stick that number onto my string and spit it out for me. We can give it a run. Let's see if it works for us. All right, so if you have 12 credits completed and you need 62 credits to get an associate's degree, that should give you 50 credits left, right? Math track so far. And if you take 12 credits per semester as a, quote, full-time student, 12 is full-time. More than that is even more full-time. I don't know, there's no like higher level, which is weird. And in grad school, 9 credits is full-time, because grad classes are more work, which is interesting. Those are just fun facts. So at 12 credits per semester, I would take 1 semester's 12, 2 semesters 24, 3 semesters 36, 4 semesters 48. I'm not to 50, so I'm going to need a 5th semester, right, to get to that 50. Right? We should be able to, we know what we put in should give us something back out. We should know what the result should be to see if it's working right. And what is it, $103 a credit? $103 a credit hour, I think, here at OCC, not the $1,297 that Lawrence Tech charges. I don't mean to trash them, but it's just kind of entertaining. Like 12 times as much per credit hour. Just blows my mind. So 5 semesters left. 103 times 50. I don't know what that is. 103 times 50. It looks like it checked out. Did the math okay, right? Because that one I wasn't going to do in my head. Seems to be okay. Now, you might be curious, and it's good to try things, right? Does it work if it doesn't need to round? Because maybe we don't trust Math Seal, because we haven't worked with it enough. That's okay. So let's give it some numbers that should come out and not round up, right? Let's try it. So if I have 14 credits and I need 62, that means I have 48 left. So if I take 12 credits per semester, that should be 4 semesters exactly. There's no partial one, right? Just working through, is it doing what I expect it to do, right? Just trying it out here. Okay, and a little bit cheaper because you didn't have to pay for those other 2 credits. So, and I should mention, in case you're not on the Discord, the Summer Momentum Scholarship opened, the application for that. If you took classes fall and winter, I think, I should really go look. I wonder if their website even works right now. But you can get money towards summer tuition, just free, which is pretty cool because they want students to come back in the summer and take more classes. So go and apply for it. It's pretty cool. Okay, questions about the lab? Does this make sense? Summer Momentum Scholarship. It's linked in Discord. I put a whole bunch of links out there because they sent me a whole bunch of stuff for other summer things too. But let's see, Summer Momentum Scholarship. Hey, it's working. Oh, here we go. Yeah, scheduled system maintenance beginning at 5 p.m. Nice of them to tell us when the page actually loads rather than it just not loading at all. Yeah, so there's a couple of criteria. So you have to have had 16 credits worth for something, and you can go read it. The link's out there. for it, but they really want you to come back in the summer. I'll be here in the summer too, so maybe I'll see you as well. But yeah, so you've got till April 21st, but it's first come first served basis. So don't wait until the day it's due, right? Just like your homework, you don't wait till the day it's due, because that makes it really hard for me to help you if you get stuck on something, right? So earlier is better. Go ahead and check that out. Oh, excuse me. Did you find the Coke Zero here on campus, or did you bring that from home? Oh, the vending machine didn't have Coke Zero. I'm drinking Diet Coke, and I'm so sad. But for a while, those 1.25 liters were on sale, and I had a stash of those in my office. And then they weren't on sale anymore, and I was really sad to like pay a bunch of money for them when I could get a 2 liter, but I can't hold a 2 liter in one hand while I teach and drink. I mean, I can, but it's awkward. I don't know. Yeah, that coffee mug is fantastic. That was my favorite. I'll bring that in next time. And I should bring in my coffee pot too. I meant to do that and forgot. Actually, I can't take the one from home. My wife would kill me. But I should get another coffee pot and put it in my office for anyone who wants coffee. Because sometimes you just need coffee. These are night classes. This is what you do. All right, so it's done. And then I did put a video out there as well on my YouTube channel. So this one here. A couple people had questions about how to get their program into Git if they didn't put it in the repository to start. So I made a video how to get your project into GitHub. Ha ha ha! I'm so funny. It amuses me. So, and I like dad jokes. So you can check that out. It's like 4 minutes, pretty quick. You can find where this one is by right-clicking on it and saying Open in Explorer, and then we just grab the folder and put it where we want it to go in your GitHub directory folder. So for me, mine's already in the right spot. I don't need to move it here. But I grab 1500. So it says, hey, I found a bunch of stuff. If you don't see a bunch of new stuff, then go open this one in Explorer and move it from the folder where it is currently into the GitHub folder. Then it'll show a bunch of new stuff, because Git's pretty awesome like that. And then you can commit and push and sync with the cloud, go view it online, and then you can turn in that URL. So we'll give it a commit summary, lab 1, commit and push. Oh goodness, I have to fetch. That should never happen. If you work on more than one computer, you have to do the fetch thing, because it has to get changes from somewhere else. This should be fine. So I'll do view on GitHub. It'll launch out to the website. You can go check out, open up your folder, open up your source folder, find your main Java file. It should look like what you just committed, right? This is our sanity check. If it doesn't look right, something went wrong. If it does look right, you just grab this URL, you give it to me in D2L, and life is good. Remember, that's the only thing that links your GitHub account to your user account in D2L that actually gets grades for things. You can use whatever handle you want. I don't care, because when you turn a URL into GitHub, your name is on it in D2L, right? And that's how you get points for things. So unfortunately, they're not linked, but that's fine. We'll go from there, and it should be okay. So you can see it all out here. So the general flow for class, right, is I'll be up here talking about a bunch of new stuff for a while. We'll take a break every hour. If I run over because I like to talk a lot, just shout at me, please. Like, really? Because I will forget and just talk and talk and talk until I get bored. Sometimes it's less than an hour. Sometimes it's more than an hour. So shout at me. After I've talked for a while, we'll start a lab where you go practice those things. The goal is the labs work for you and you can get them done, right? Ideally before you walk out the door. It's not always the case, and that's okay. Everyone learns at a different pace and different speeds, and whether or not you actually did the reading beforehand or you do the reading after is going to impact that as well. That's fine, all up to you. But if the labs are not going well for you, go get tutoring. Come see me in my office hours, right? That means you need additional practice. Well, that's okay, right? It's fine to get additional practice. That's why we have the Academic Support Center. That's why we offer no additional charge tutoring. Remember, it's not free because your tuition and tax dollars pay for it. Thank you very much. But no additional charge tutoring, because we want you folks to be successful. After I get a couple grades in, I have cool automated alerts that say, hey, if your grade's not at a certain level, you get an email from the system that says you need to go to tutoring. That's what it is. I'm going to be honest. If you're not doing well, go to tutoring. Right? I have 20 minutes per credit that I teach contractually that I have to have office hours for. It's a whole weird that's okay, it's a formula, for office hours, I'm happy to meet with you and talk. I try and do 15-minute appointments because I have 5 classes with a little less than 30 now. People have dropped out of each one, which is okay. Things happen. But like 150 of you folks for 8 hours worth of my time each week for office hours. The tutors have a lot more time. So I'm not trying to pawn you off. Like, I'm happy to talk with you and answer questions and do those sorts of things. I love chatting with people. I'm a very people-y kind of person. I like to talk a lot, as I'm sure you've noticed. So happy to help with what I can, but again, I'm limited to about 15 minutes a week or so with you folks. If I've got open time, I'm happy to meet with you more often, but I'll make sure I can meet with everybody across all the classes. So yeah, that's my plug for tutoring. And then you do get bonus points as well on your labs and quizzes, which is fantastic. I'm happy to throw those at you. But if labs are going well for you, that's a good sign. If they're not going well, go get more tutoring. Kind of keep a tally for yourself, right? We talked about the first week, a college class expects about 2 hours of work outside of the class for every hour in the class. So we're looking at 4 hours a night, 4 hours a week for just the first time you see stuff, and then 8 hours a week for your homework, your readings, your practice, you're doing the quizzes, you're doing the book stuff, you're going to tutoring sessions, whatever that happens to be. If you're putting in 8 hours a week or so and it's still not going well, let me know. If you're putting in 4 hours a week extra time and it's not going well, you've got a gap there. And that gap will add up week after week after week after week. If we get 6 weeks into class and you've only put 4 hours in extra, you're about 24 hours behind, right, worth of work. That's sort of how the formula works. So I've got people, often enough they come to me and they're like, oh, I come to class, but I haven't done anything extra. So they're 8 hours a week behind for 5 weeks. I'm like, well, you're 40 hours behind now. Do you have a full-time job? Yes? No? All right, well, this is your full-time job now. You have a week to catch up 40 hours. It's rough. You don't want to have to spend 40 hours a week on Java, right? That just, it's bad for your brain. You got to do other things. So, all right. That's not scare. I'm sorry. I'm not trying to scare people off, but just set some expectations here for how it's going. So ideally the labs are good. They go well. If you got to do some more readings, more practice, that's okay. As long as you're getting it done by next week, that's perfectly fine. We're within that 8 hours of extra time that you're putting in for the class. Good. If it's not going well, reach out, let me know, because I've got a lot of you folks. The only thing I see is scores. I'll go look at the grade book and see how things go. You'll get automated emails, that sort of stuff. So I feel bad when people fail. I do. It happens. I don't like it though. I don't enjoy failing people. So I know I'm a little weird, but I don't like that. All right, we're doing new stuff now. We're moving on. Awesome. So we are on to chapter 3. So in chapter 3, it's a little all over the place. So we're going to be all over the place as well, trying to kind of pick apart the starting stuff, and then we'll get into the more complicated stuff after. So we got about 2 weeks here on our plan for chapter 3. Where to go? Down here. Right. So if, else, and switch is the focus of what we're doing this week. Next week, we'll look at the whiles, do's, and for loops. If it doesn't make any sense, that's okay. It doesn't have to. You haven't read it yet. No worries. We'll talk about it here. So we spent about 2 weeks on this chapter. It's a pretty big chapter. We're going to have a lab tonight, and then we'll have Project Zero as well. So the labs you should be able to do after sitting through class and doing the reading relatively quickly, right? It's your chance to practice this. The projects are going to take more time. They're a little bit more involved, have some more steps, have more stuff going on. I still help with projects, but I don't solve them for you. If you got stuck in the lab and reached out this week, I sat with you and we chatted or did a Zoom call or something, and I basically told you what to write for anyone who met with me. I'm happy to do it with labs. Labs are your chance to practice, participate, make sure it's working for you. Projects, I don't give you answers, right? I'll get you pointed in the right direction, say, oh, hey, you probably got to go look up this concept here. You're going to use this concept, apply it over here. So the projects are bigger, they're more complex, take some of that, okay, I've done it over here. Now, how do I make it work for this? That sort of thing. Hector, my friend, thanks for donating to the Student Scholarship Fund, the University of Michigan Dearborn College of Engineering and Computer Science. You, my friend, are amazing. Okay. So if, else, and switches. So in part of this, actually, we do want to come back to chapter 2, this section 5 that we kind of breezed over. So most of this, what we'll work on next week, is going to be a little more important here. So in section 5, we did the arithmetic, increments and decrements. This is adding to numbers or subtracting from numbers, those some shortcuts. The relational operators is the important part here. So with relational operators, it's saying, is something equal to something else? Does the value of A equal the value of B? If A and B are integers, great. Are they both the same number? That's easy. It doesn't work with strings. We'll talk about that in a little bit. This is not equals. Are they not the same value? So if we say if they're not equal, right, it's the opposite of if they are equal, which sounds funny to have to say it like that. But so this will be true if they're not equal. This will be true if they are equal. So the results of relational operators are either true or false. Right? It either is or it is not. Excuse me. So is A less than B? Yes, it is, or no, it's not. True, A is less than B. False, A is not less than B. Right? So all of these are going to boil down to true or false, which is a Boolean. That's our fancy word, Boolean valued expression. It's just fancy. Boolean means it's true or false. It's on or off. It's a 1 or a 0. So these are ways of comparing values here. You can compare numeric types. You can actually compare characters. That's singular characters, right? That's the char type that we mostly are going to ignore because it's not all that useful. Not strings. Strings are a whole different animal. But characters, the reason why this works, behind the scenes, a single character is actually stored as a numeric value. So there's this thing, did we talk about the Unicode table or ASCII? So if you search Unicode table, every character has a numeric value that it is represented by. So the capital A is 65. I shouldn't know that, but I do it often enough, that's in my head. So if you store a single character of the letter capital A, you're actually storing the number 65. Java just translates it for you because you told it it's a character. It's fun magic, that's fine. Not all that interesting aside from that, but because characters are really numbers, you can say, is this character less than this character? So capital A is less than capital Z, because the number 65 is less than the number, oh goodness, 90. Sure, 65 is less than 90. Yes, that's true. Does A being less than Z really mean anything? No, not really. We don't really care. But it's there. So greater than, less than, equal to, it's good for numerics. Doubles and ints. And all the other types that you can use if you care to. But doubles and ints we can compare. Okay. You can do some really weird stuff here. This telling Java, hey, I want a Boolean variable here. I'm going to store a value of either true or false. I'm going to call it same sign. So Java will go out and store a location, give you a location in memory to store a true or false value. Yes, it's true. No, it's false. Right? Either way. And then you're going to assign it a value. The value we're assigning it is, okay, well, it's, order of operations here. Let's do some parentheses. X greater than 0, Y greater than 0. This is either true or false. True or false. And then we're saying, okay, do these two things equal each other? Does true equal true? Okay, they have the same sign. They're both positive. If they're both negative, false equal false. Are they both negative? Yes, that's true. It'd be true. If X is positive and Y is negative, we'd have true on this side, false on this side. We say, does false equal true? No. So our same sign would be false. Really funny, but you can combine all sorts of operators here, checking these sorts of things. Again, not strings. We'll get to strings in a little bit. Okay, so that's relational operators. Do values equal other values? Are they greater than other values? Are they less than other values? These sorts of things. So this is the exclamation point equal sign is not equals. It's kind of fun. Not only can we do that, but now we can combine Booleans. So I can take a true and false and combine it with another true or false to get another result out. So the example I always like for this is when you go to McDonald's and they say, do you want a burger and fries? You say no, because McDonald's fries are nasty. You do not want McDonald's fries. They're gross. They're just awful. Go get better fries. So do you want burger and fries? No, because I don't want the fries. I don't care what the other thing is. I don't care if it's a quarter pounder with cheese. I don't want the and fries. So if any part of an and is a no or a false, the whole thing is false. If they say, hey, do you want a burger or fries? Then you can say, yes, I want that quarter pounder with cheese, because they've told me that it's cooked fresh, and I will cling to that and trust that the burger's cooked fresh and has not been sitting in the warmer for who knows how long, and the health inspector's not here, we'll just put it back in. they cook those fresh, right? Just humor me. Okay. What? Yeah, I checkers. So I used to eat a lot of fast food until I started being a vegetarian. Turns out there's not a lot of vegetarian stuff on the menu. Like you can get the Beyond Burger at some places. It's okay. Um, I don't know. I had one today and it didn't agree with me. So that's all right. So it's a Boolean operator. So there are ands, ors, and nots. So with an or, if either side is true, the whole thing is true. Do you want the burger or the fries? If you like those greasy, nasty fries, you say yes. Go for it. You can, as Dr. Boss says, they're just a ketchup delivery system. We don't get them for the fry. We get them because they scoop ketchup. Sure. So if either side is true with an or, the whole thing is true. If either side is false with an and, the whole thing is false. Because you want both of them when you're saying and, both have to be true for it to be true. So we're combining these Boolean operators. So to do that, you use the ampersand sign for and. For or, it's pipe. That's the shift / key over the enter key. We almost never use the pipe character, which is fun, but that is the or sign. And Java is actually smart here, and it's written by developers who are lazy. We want to do the least amount of work possible. So these are technically short-circuited. What that means is when you go check out the first value here, and you're going to AND them together, if the first value here is false, Java says, oh, this is false, the whole thing is false, I can ignore this over here. I don't care what's on the right, because if this side is false, the whole thing is false because we're ANDing together. Right? That's a short circuit. It's going to not do the extra work because it knows the whole thing is false. It does the same thing with ORs. If the first thing is true with an OR, it doesn't even look at the second thing. It says, oh, one part is true, and you're saying OR, so if either part is true, the whole thing is true, I'm just going to go for it. The whole thing is true. So it saves a little bit of time here. Behind the scenes, I'm sure it adds up eventually. For our purposes, we don't care too much. It does a couple cool things later on because it short circuits we can look at. But and then the not here. So not is technically a unary operator. It operates on one thing. So not gives you the opposite. So not true is false, and not false is true. Right? Sort of makes sense. And that's why this is the not equals. Right? It's if it is equals, opposite. It's not equals. Right? It essentially is doing the same thing here, saying if they're equals, not. Right? So we get ways now we can combine our Boolean operators. Now this doesn't seem very interesting here, but we can start doing some fun stuff with this arithmetic now here based on what's happening, and we can start using those expressions and say, okay, if something's true, I want to do something. If it's not true, I want to do a different thing. Right? So we can start using these as we go. There's a conditional operator. I don't like this because it confuses me. Some programmers think it's really funny to write things on one line because it only took them one line instead of 5 lines. Sure. So this is technically valid code. I don't like this, and it confuses me, so I don't use it most of the time. We'll come back to this. Don't worry, we'll come back to it in a little bit. And doing type conversions. So remember I mentioned this, when we have math seal, always gives me a double. So we said, hey, number of semesters left is just a double. That's fine. It wanted the double here. So ways that you can get around that are you can convert your types. So Java will always let a smaller thing fit in a bigger thing. So integers can always fit in doubles because doubles are bigger. There's more room to store information in a double. Shorts are smaller than integers. You can't give an integer to a short because Java says there's not room here, it won't fit. And I think of like that stacking block puzzle, right? As you put the rings on, the rings stack, smaller things will go on top. It just doesn't fit. You can't automatically convert. So if you want, you can force it to convert. This is typecasting. You can say, hey, Java, I really want it as this thing here. If it doesn't fit, that's on me. I did a bad thing, but I know I did a bad thing. So I'm okay with it. So you can say, hey, please treat it as this type. So the other option we have, instead of saying this number of semesters left should be a double, we can leave it as an int and tell Java, hey, that whole thing, I want you to pretend like it's an integer. So this is doing typecasting and saying, forcing it, whatever the number you get back here, jam it into an int. If I lose some decimal places, that's on me. I know it's going to happen. Now, with Math Seal, we're not losing any information because we know there is no decimal place to lose. Java's not that smart. It doesn't know that we specifically rounded first. It doesn't have that concept. So we have to typecast it and say, really, I want it as an integer. What that's going to do is get rid of the 0.0 for me. So when I get my output will look ever so slightly prettier now. And we can say, yay, it looks prettier. So you can do the typecasting here if you want. What is this? 2.5.6. Are notes useful for you? 2.5.6. I can drop those in. I'm happy to do that. Okay, so just shout at me, because generally I try and give different examples than the book has, because that way, like, you'll see it from me once, you'll read it in the book once, you'll practice in the lab once, and then you'll do it in a project once. And that's like 4 times, probably 5 by the time you had to read it 2 or 3 times. So the more often you see something, the better it's going to stick, right? This idea of your repetitive learning. You're really learning a new language. It's not Spanish or anything, but it's another language you're learning here. So you've got to practice it here. And the only way to get better at it is by doing it and writing more code. And you can read all the code you want, but until you go and write it, like, you can listen to Spanish all day long, but until you go and speak Spanish, you're probably not going to get very good at it unless you go practice it and speak some Spanish. So same idea here. So if you're looking for more things to do for practice, at the end of the chapter of the book, he has programming exercises that go and do something. And then he has all the solutions out here as well. So try to do the thing and then check your solution. See how it worked for you here. Definitely worthwhile here. If they're easy, great. It's not going to take you very long. If they're hard, maybe we got to do some more reading, do some more practice, that sort of thing. So keep that in mind as well. All right. Conditionals, type conversions, great. Precedents. Not only do we have, please excuse my dear Aunt Sally, right? Our parentheses, our exponents, our multiplication and division. Please, please, please know that those are the same level of precedence. We do them left to right. I know I said it last week. I'm going to say it every week because I cry when people do it wrong. It makes me really sad. That's okay. But now we have additional precedence rules for our relational operators, our unary operators, and our Boolean operators. Now, most of these make sense because these unary operators, like plus plus, like add 1 to a number, you have to do that first before you use the number, right? Or nots happen first, or negatives happen first. Like -2 times 3, -2 happens first. Sure, it's not going to make much of a difference, but that one happens first. So the unary operators, then our multiplication and division. Again, parentheses he skips, but that's fine. And modulus, that gives you the remainder result. I think we talked about this, the integer remainder. We talked about modulus? Okay, someone's shaking their head, thank you. Is technically division, right? You don't get the quotient, you get the remainder. That's all. So it is a division operation. Then addition and subtraction. Once you've done your arithmetic stuff, then we can check relations, right? So I have to resolve my arithmetic first. Does 2 times 3, is that less than 5? I'm not going to say is 3 less than 5 true times 2. And that just doesn't work. You can't multiply true and 2. So do your arithmetic first, then do your relationals. And technically, greater than and less thans are higher precedence than equals and not equals. So if we have something like, hey, is this one, where did that one go? Up here. I think it was this one, right? Which makes sense. I have to do the greater than and less, even if we didn't have the parentheses here. The greater than and less thans would happen first. It's not going to say, does 0 equal y, x greater than true or false, right? It just can't work that way. So if you think about it for a little bit, the order of precedence makes sense, but you don't have to memorize it. You just come look up the table here, right? It's all out here for you to look up. Ands happen before ors, so this one always catches people, and I never remember which one's which. I just go Google it here because it's not worth keeping in your head. If you're doing ands and ors, I said and twice and that felt wrong, but if you're doing ands ors and ands, if you're doing both of them, just use the parentheses. Like, force which one you want to have happen first, with parentheses, don't rely on the order of operations because we're probably going to screw it up. Is that a question? With ands, both sides have to be true for the whole thing to be true. Yep. Then the whole thing is false. Yep. With ors, if either one is true, the whole thing is true. So if you want the burger or the fries, either one of those, if you're hungry for burger or fries, you say yes. Right? With an and, because you hate nasty McDonald's fries, you say no. And the whole thing is false. Just don't give me an order here. Their cookies are okay though. Weirdly, like I don't know. They're deep.
How would no's work?
The
same
not
range of ands. Of knots, I'm sorry.
So knots are unaries, so they happen first. So like not something is going to happen first. I don't know if we have got a knot here. We can go back to a knot here in a little bit. And the last thing before typecasting, because we love shortcuts here, these are combined assignment operators. I love shortcuts here. So if I'm going to take a value and add something to it, or multiply by it, or divide by it, or modulus by it here, I can shortcut it here and say, hey, I want to subtract y and then assign it back to x. I want to multiply by y and assign it back to x. Right? So saying, because everything on the right of the equal sign of the assignment operator happens first, we do right assign to left. So it does this and then assigns it back to x. We said that's a lot of typing. I don't have to type x twice. I'm just going to say, hey, multiply equals. Now the funny thing is, this sometimes works backwards. Not all the time. Depends on which one you're doing here. So if I was going to say, hey, let's go add some costs, because every semester we charge a registration fee because we can, I guess. It pays for the registration people, I guess. I don't know how that works. So we could say, hey, your remaining cost equals my remaining cost plus 100. We'll charge you a fee here. And maybe that, times the number of semesters remaining, right? We could say it's $100 per semester. Why not? It's probably close. We could do that, but now I've typed remaining cost twice, and I'm lazy. I don't want to. So the shortcut way of doing that is saying remaining cost plus equals 100 times the number of semesters left here. Right? These two are the same thing here. It's just a shorthand for saying add to this value. Now, what's bad though is if you do it backwards here, Java says, okay, you want to assign positive 100. Remember, because Java basically ignores spaces. So equals plus 100 is saying I want to assign the value of positive 100 times the number of semesters left. I've just given you a really good scholarship. You're really happy. School's going to be mad at me, right? So these are not the same. So you have to be careful. And it's not going to yell at you. The only thing you get is it's gray. And it's saying, oh, it's unnecessary because 100 already is positive. You don't have to tell Java it's positive 100. It knows it's a positive number. Like that's our default here. Sorry, let me put my phone on silent here. So do be careful with these combined assignment operators. Now, plus and minus are really the only one it happens to. If you're multiplying by, it's just not going to work because you can't say equals multiplied 100. It doesn't know what multiply 100 means. That's not valid. But the plus and minus, it's like, okay, sure. You want plus 100 or minus 100? I'll give it to you. So this one is bad. The wrong way. Right? And then these two are the same.
Same what though?
The exact same thing happens. So remaining cost gets what the current remaining cost is, adds $100 per semester. So, and then it takes that answer, stores it in wherever I'm saving remaining cost. So if remaining cost was 5,000 or 4,944, it's going to say 4,944 plus 100 times 4 plus 400. 5,344 is going to get saved into remaining cost. We'll say, hey, remaining cost, you now have a new number that you're remembering for me. Here's 5,344. This does the same thing. It says, hey, remaining cost, add something to yourself. What you're going to add is 100 times the number of semesters left. Go add 400 to yourself and update. So we kind of skip the assignment operator. We're combining addition with assigning, saying add and then remember the new number. Rather than, hey, remember this new thing. Everything that happens on the right happens first. Save it back on the left. So it's a little shortcut. I'm fond of these. Maybe I do them often enough they don't look funny to me anymore, but if I don't have to type the same word twice, I mean, I only hit like 2 letters in tab, but it makes me happy. Okay. All right, so that was the end of chapter 2. Now we can get into chapter. Well, I guess we should wait a second before we get into chapter 3 because we're about to go on break here. Now that we know if I can compare greater than, less than, or equal to, we can do something interesting in our code and start making the code be even more interesting to say, hey, you know what? If you're going to pay more than $5,000, maybe the school is going to offer you a discount. We're just imagining here. This is just rainbows and unicorn land here. But, if this were the case, our code can say, hey, maybe you're eligible for a scholarship. Hey, we got the summer one, right? Maybe we're giving away some money. And starting this fall, if you folks are still around, which I think you probably will be, if you are enrolled in a CIS program, so your major is declared as one of our CIS associate programs or certificate programs, there'll be a new CIS specific scholarship out there you can apply for. It's only going to give out $500, but $500 is $500, right? And no one's going to say no to that. So there's only one of them available to start because the scholarship's new. It's kind of fun. OCC has a foundation that runs endowed scholarships, and if you give them enough money, then they give out scholarships like forever. Because generally we don't lose money. I mean, yes, things happen and all sorts of weird nonsense, but they say on average they can give away 5% of the scholarship fund. So once the scholarship fund hits 10 grand, they start giving away 5% of it every year, which is cool. So that'll be coming once I have more info on that, probably closer to summer. I got to pester those people. There'll be another one, but that'll be for fall, so not summer. But I mean, we do try and give some money out. I know there's like a lot of you and only one of those amounts, but it's only so much we can do. Trying here. All right, so why don't we take 10, and then we'll come back and pick it up with actually chapter 3. That was just a psych out the first time. There we go. I gotta bring in the turntable so I can like bring that down a little better, faster, or a little nicer. All right, what was that? Oh yeah, it's like Metroid Remix. The guy doesn't stream anymore, but he used to stream his music creation. It was really fun. I know nothing about it, but like it was really interesting to watch him generate music. Um, I thought it was fun. He's probably busy now. All right, so moving on to more interesting things now. So I'm going to leave this where it is here in lab one. I'll go commit those last couple changes. So this is the other fun thing. As you change your program, you can commit as often as you want. It's mostly free, right? There's a little bit of electricity here, but we don't really care about that. Okay, we feel bad about it, but it's fine. Just pretend like it's free. So you see, hey, this line changed, it's red. This line was added, it's green, and it tells me at the line level. So like, hey, 23, 24, 25, 26, 27 didn't change at all, but 20 and 21, or 21 and 22 were added. So like Git is smart enough to see specifically what lines changed. And this is important later on when you're doing much more interesting stuff with more people. It's good at putting multiple changes together. It's not great at it, but it's better at it because it knows what happens at what line. So it works out relatively well. And then you can see kind of the history of what changed in this file, which is really fun. So if you want to go back, be like, oh, hey, you know, what happened back then? You can look at this entire history here. So this is adding the registration fee per semester. I think that's what we did here. So I'll commit and push that. All right, so I'm going to start a new project for week 3 here. This is week 3 conditionals or control statements. And let's see if we get a little starter here. Make sure it builds and runs. Should be fine. Every so often it gets weird though. So, all right, awesome. So we get hello world. Looks good so far. So what we want to do now is we want our code to do different things based on if something is true or false. Right? Now we can start having our code make decisions. We can control what happens in the flow of our code. So far it's been the first line runs, and the second line runs, and the third line runs, and the fourth line runs, and the fifth, and everything runs no matter what, which is okay. But we can do more interesting things if we can control stuff conditionally and say, hey, if something's true, I want you to run. Right? So we can, let's just kind of shortcut here. So we'll say scanner keyboard equals a new scanner, given system in. Nope. And then we'll have, let's just say here's a double for total cost is double.parse double, right? We're going to convert here of keyboard.next line. Again, I'm not typing most of these things. As soon as it's suggested, I just do tab or enter. It's filling it in for me. I type fast, but not that fast. If you're ever bored and want to play Type Racer, that is entertaining to play Type Racer sometimes, and we can see who's the fastest typer. It was last time I checked. Type Racer? Play Type Racer? Yeah, it looks like it is. Wow. Enter a typing race. Oh, hang on. It didn't start yet. Oh, when the race begins. Oh, we're not ready yet. Let's see. Is it going to go? Oh, I hate the extra keys. Ah. That's a red card. Oh, goodness. I'm embarrassed now. Oh, no, we did it. That was me, right? Yeah. I was only 76. All right. Anyway, we can do that sometime. You can all join in a race and have some fun. So, double parse double of whatever they type in. We'll get some number here. Now we can say, hey, what rule do we want to have in place? What makes sense here? So we said, hey, if you're going to spend more than $5,000, maybe we'll give you a discount. Again, we're making things up here. We can be pie in the sky all we want. This is our program. It's not actually hooked up to anything. So we can say, hey, if. So if is the keyword, and we say if in English. Works out pretty well here. Like if you're going to spend more than $5,000, if your total cost is more than 5,000, let's give you a discount. So if, and then we do a set of parentheses. If loves parentheses. Most of our code loves parentheses here, and that's okay. So what we put inside the parentheses here is a Boolean valued expression. something that will be true or false, right? That's either relational operators or equality, right? Equals, not equals, right? Or relational greater than or less than, or we can combine multiples of those. So for first, we can just say, hey, if the total cost then is greater than or equal to, maybe, yeah, why not, 5,000. Then the next fun thing here is ifs get a set of curly braces. So far we've done everything inside this main set of curly braces. We're going to add more curly braces. So I start a curly brace and I hit enter, and IntelliJ says, oh, you want an ending curly brace, don't you? Yes, please, IntelliJ. I like when you type stuff for me. So if you type it in yourself, it's okay. You're welcome to type it in yourself. Doesn't really matter, right? As long as, and when I click on the ending one, notice it highlights the starting one, or I click on the starting one, it highlights the ending one. We always have to match. If you open a parenthesis, you end the parenthesis. If you open a curly brace, you end the curly brace. If they don't match, Java gets real upset with us and we get a bunch of red lines here. Now, we don't get the red line here because, again, Java doesn't care about the white space, right? It could all be on one line as far as Java cares, but what Java says is, hey, it got to the end of the file here, class or interface expected. This is not a helpful message here. Thanks, Java. It has an extra curly brace. So that's really the only thing. So we just have to kind of know that's what that means here. I have too many. Okay. It's not great, but that's what happens. So once you fix the extra curly brace, it goes away. Life is good. The other thing you can do here is if you have a lot of curly braces, you can go to code and you reformat code here, or reformat your file. I think it both do the same thing essentially, and it will try and fix all your tabs for you, which is really nice. So anytime there's a curly brace, you notice everything's kind of tabbed in inside of that curly brace. It's just a visual cue for, hey, it belongs here. So when I auto format my code, now all of a sudden I have two down here along the left hand side. Hey, wait, that looks funny, I have an extra one. So the format code will try and line them all up for you, and then you can see if you have too many. If you don't have enough, you also get a red line here. Now this red line, when you hover over it, says, hey, a curly brace is expected. This one's helpful. Sometimes it's hit or miss with these error messages. So, I go put it in the right spot. You could just put it anywhere you want here and then go format it again, right? Code and format code, and it'll fix it for you. Life is good. Now, there is one caveat here. Technically, these curly braces are not required if the only thing you're doing in an if statement is one line of code. Just pretend like you never heard that for my purposes, because it's a really bad habit. Now, if you get out in the company and they say, this is how we do our code, we will always skip these. If we just have a single line here, just smile and nod. It's not worth arguing. But I am old enough to remember, years ago, the Safari browser on Mac, back when Macs were like, hey, we're perfect, we're great, we never get viruses, everyone loves Macs, yada, yada. I hate Macs, but that's my own problem, not yours. Safari had a bug where the secure connections, HTTPS connections that are supposed to be secure and encrypted, could be broken because one of their developers did not use curly braces. And they had two lines of code that were supposed to run. So just always use them. It doesn't hurt anything to have them. It's a good practice. We're always going to use them here. Technically, you don't need them. If I see it, I'm not going to mark you down. I'll just make fun of you and say, hey, you need to use the curly braces. It's okay. So what we do here then, so if total cost is more than 5,000, right? And we kind of just read it just like that. If total cost greater than or equal to 5,000, if total cost is more than or equal to 5,000, what do we want to do? Let's give you a discount. Let's say, hey, total cost, what kind of discount do you want? Do you want like a flat amount? Do you want a percentage amount? Do you want what? What should we do here? We're making it up. It's our pretend. 30% discount. Okay, so we'll say times equals 0.7. Right? This means you're paying 70% of that, which is a 30% discount, right? I think that's how math works. Sometimes you got to check me because I'm not great at arithmetic, but usually I can make it work. So if you're spending more than 5,000 or more, we'll give you a 30% discount. So if this is true, this code runs. What do you think happens if this is not true? If total cost greater than or equal to 5,000 comes out as false, what do you think happens? It doesn't run. Look at that. It just skips over. It says, oh, it's not true. I'm going to skip to the closing curly brace. Just jump. Skip a bunch of code. And then we can print out your total cost is, and then a $sign because we like things to be pretty. Why not total cost? And if you want, right, you can have more than one line of code inside of this set of curly braces. You can have as much as you want in here. Let's spit out a message here. You get a scholarship. Sure. So we'll give you the discount and tell you got a scholarship. And then we'll tell you what the total cost is. So if we give it a run, it's just sitting here waiting. We never ask them to enter anything, right? You can do keyboard next lines and it just sits and waits without telling the user anything. Now, I know what I'm supposed to enter because I'm sitting here talking about it, but it's probably good if we tell them what to enter here, right? So we can say, hey, enter your total cost, right? And then we rerun that here. So, okay, enter your total cost. What is our estimated total cost? What do you want to try first? 5,000. Okay, so if it's 5,000, are we going to get the discount? Yes. Okay, so we should get the discount. 70% of 5,000 is something. I don't know. We'll go do math later. We got a scholarship, $3,500. Okay, that makes sense, right? 10% is 500, 30% times 3 of that, 1,500 off. Cool. We just gave ourselves a scholarship. So it works if it's true. Let's try and see if it works if it isn't true, right? If it's false, let's just give it a shot and see if it goes for us here. So enter your total cost. Let's just say, hey, it's 4,000. Your total cost, 4,000, right? It didn't run. It just skips it here. So if it's not true, or if it's true, the code block runs. So stuff inside a set of parentheses, we commonly call a code block, some block of code, right? Everything inside the set of parentheses is a block. It's like one group here. This block will run or it won't, right? Based on if it's true. So now our code can make decisions and things can happen if something's true, which is kind of fun. Now, if you wanted something to happen if this is not true, right? If you don't get the scholarship, maybe we just tell you, sorry, you don't get a scholarship. We don't change the total cost at all, but we should at least tell them, hey, thanks for applying. You didn't get it. Sure, why not? So what we do then is attached to this if then, we give it an else. So if something's true, this happens. Else or otherwise, this other thing happens. So we say else and then another set of curly braces. So you can attach an else to an if you want to. You don't have to, but if you want something to happen, if it's not true, that goes in the else. So you can say, okay, otherwise, sorry, you don't get the scholarship. So if we have an if and an else, we know that one or the other will run. It has to, because either it's true or it's false. If it's true, the if runs. If it's false, the else runs. Oops. There it is. If the above if is false, the else runs. Right? So this one or this one. Our technical term for that is mutually exclusive, right? One and only one of those blocks can run. Either this one or this one. Java's going to skip one or the other, right? Depending on if this is true or not, which is nice. So we either tell them, yes, you got it, or no, you didn't. It's a pretty straight cut decision here for our scholarship. Hey, happy Tuesday, Apex. Thanks for dropping on by. So, yeah.
Perhaps a bit of a dumb question, but would it be able to tell? Because eventually people would write 5, comma, and then the 3 zeros. Would it still be able to run the if you were to write it in a conventional way? 5, comma, 3 zeros.
So double parse double doesn't understand commas. You would think it would understand commas. Java just pukes on it. So if I say, hey, it's 5,000 with a comma, 5, comma, 0, 0, 0, I get this ugly red stuff here. Number format exception for input string, quote, 5,000 at double parse double. Not super useful here, but it's saying, hey, number format, the format of this number here, Java has no idea. Java's a little bit dumb when it comes to numbers. There are other ways to convert numbers that are smarter, but that's down the road. We don't even touch it this semester. It's not like we'll just assume we get good input. That's about as good as we can do for now. So yeah, so if they enter bad stuff, we just puke on it. So, or if they type out the words 5,000 spelled, it'll also puke. Yeah, so input's a little tricky here when we're dealing with scanner and keyboard input, because people typing stuff in is awkward. You know, when we get to graphical programs, we have more control over what gets entered, and we can do validation and checks and all sorts of fancy stuff. Like when you're filling out something on a website and you are supposed to give it numbers and you put a letter in, you can like pop up a red box and say, hey, you know, numbers aren't allowed or letters aren't allowed here. You can do more stuff visually if you're not just typing at the console. So we ignore it. It's a little lazy. But it would be nice, right, when we're having these number literals here, and I have a number in here, you can add underscores. And Java says, sure, I'm going to ignore your underscore. It's just a visual cue for people. And I think we talked about this, maybe?
Mhm.
Okay, so you can put underscores in your numbers. The downside is you can put underscores in your numbers. Java doesn't care about underscores in numbers. So, you know, with great power comes great responsibility. Don't put them in stupid places, because Java will let you do that. So I can have 5,000 written like this, and it's just dumb. So just be careful with that. But it's nice to put in your digit separator in literals in your code. You can't do that when you're typing with scanner. So that's the downside. So we get an if or an else. One or the other will run here. They're mutually exclusive, right? Either the if block or the else block. Okay. So the next thing we can do is pretend we're a bank, because that's fun. So we'll ask the user two questions here. One, we're going to ask them how much does I guess we can do three questions, right? How much does the house they want to buy cost? How much is their down payment? And what's their credit score? Because we boil everyone down to a number, because this is what we do. Yeah.
At the end of line 17, do you need a curly brace?
So this one is going to run regardless of the if or the else.
Oh, okay. No, I'm just wondering.
Yep. So the curly braces, this is the else block here for just this one line.
Yep.
And this is the if block here for these two lines. So as long as they match here, we're good. Yep.
Just wondering.
So we'll ask them three questions. So probably a double here for the house price, and we should ask them, right? You know, enter price of the house you want to buy is double.parse double of the keyboard next line. Great. And then again, we'll repeat. I don't want to type all of it, so I'll just copy paste. Enter the down payment you have. This will be down payment. And then this is probably an integer here. I guess it doesn't matter too much. Integer, parse int. Enter your credit score. Ooh, I got an enter mode. That one's ugly. This is credit score. We'll ask them for three things, right? How much does the house cost? What do they have to put down on it? And what's their credit score? Okay. Now, the logic we can do here can be slightly more complex, right? Because we can start saying if something is true and something is true, right? So we can do some quick arithmetic here. So we can say, okay, if the house price minus the down payment, or maybe we take the down, how about down payment divided by the house price? If that is greater than or equal to 0.2, right? If your down payment is 20% or more of the house, we're happy with you, right? You've given the bank enough money towards the house that if they foreclose on you, they're probably not going to lose a lot of money. Just an estimate here. So if this is true, we'll pretend we don't care what your credit score is. Doesn't matter. So we'll say you can get a mortgage. I'm not in the mortgage business. I'm making this stuff up here. It's probably close-ish, but they have software that does all this stuff nowadays anyway. So great. Okay. So first way you qualify, if you have 20% or more to put down on the house, right? You get enough skin in the game that if things go south, the bank takes your 20% and runs and kicks you out, right? Sure. If this is not the case, then what else do we want to check? So we can now have another check if we want here. So if this is true, great, right? Or maybe we'll put it in here. So we'll say, hey, if you have 20%, maybe, or, right, this or logic here, we can say if this is true, or the other side, if your credit score is greater than 800. Again, I'm making up numbers here. I have no idea if this is actually close. So we'll say, okay, if you can put 20% down or more, or the bank thinks you're going to pay them back. If either one of those is true, they'll probably give you a mortgage, right? Otherwise, we can say you don't qualify. Sure. So with an or, right, if either side is true, then the whole thing is true. If they're both true, great. That's fine, right? But only one of the two needs to be true for it to be true. Sorry, the screen gets kind of low over here. I'll try and keep it up higher. So we can combine them here and say, hey, if this one or this one is true. Now, what if we want to have additional rules here? What if we want to say, okay, well, maybe that your credit score is not all that good, but you can do 10% down on the house. We might give you a mortgage. Can we do that? Yeah, you can and or as much as you want, like until you go nuts. Go for it. So again, order of operations is your friend, but just use parentheses because it's easy. So I'm going to do another set of parentheses here to say, okay, this thing first, right? Or another thing. So all of this is true, or another thing over here. So if our down payment is greater than or equal to 10%, right? This and my credit score is greater than or equal to, we'll say, how about 700? Again, we're making stuff up here. So we're going to say, if this and this is true, take all of that, boil it down to a true or false, and then or that with all of this, or together. So if this or this is true, or this is true. I guess these are actually kind of redundant at this point, because if this one is true, or this one is true, or all of this is true, probably is not going to hurt to do this, but it's okay. We're just checking it here. Right, so we can add as many of these cases as we want here. Now, the problem is, this kind of hurts your head, right? This or this and this or this, but not that, or like, it starts to get a little complicated. So what do we want to do? Well, let's try it. If I give it something where my down payment's 20% or more, I should get back yes. If I give it something where my credit score is more than 800, I should get a yes. If I give it something that is not this, but that this is true, both of this and this is true, right? So if I got 10% or more of a down payment and I'm 700 or more, but less than 800, right? So we need to be able to think through step by step by step. What is the condition? What is the rule here that we're trying to put into code so we can go and make sure it does what it's supposed to do, right? Sometimes it's hard just getting it down on paper, just in English. Okay, what needs to be true? 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 But once we get it down in English, we can start translating it to code and then try it. We get bugs all the time. Bugs when the software doesn't work, but it doesn't do what it's supposed to do, we call it a bug. A long time ago, you used to do software on index cards and you had to punch holes in them, and my father has them in his basement because he won't throw things out ever. And they're cool, I guess. Like, it's nostalgic, sure. But if an actual bug got in someone's note card one time and the computer couldn't read the card, and that coined the term, there was a bug in the program. It didn't do what it was supposed to do from a physical bug, but now we call them bugs because some old person said it. I don't know. We call them bugs. So if it doesn't do what it's supposed to do, it's a bug. What?
They just said exactly what happened.
Yeah, I mean, it was a, yeah. Yeah, there's not cockroaches in Java, but sure. We'll pretend like it is. We can blame the bug. So if it doesn't do what it's supposed to do, that's a bug. That's a problem in our software. It's not working as intended. So we need to try it and see, test it out, make sure it's going to work right. Yeah.
This is a little stupid, but could you, in like comments, basically translate what the first and two statements are?
So down payment of 20% or more equals yes.
Oh, thank you.
Credit score of more than 800 equals a yes.
Thank you.
And then we have down payment of 10% or more plus credit score of 700 or more equals yes. Is this
that's really
plus helpful here? I mean, and maybe can I say and? That's probably better than plus. Because this is the and here, right? This and this have to be true. Okay. So total cost. What is the this is the number we're ignoring here. That's fine. Okay, we didn't get the scholarship. That's fine. What is the price of the house we want to buy? Let's do 100,000 because that makes the math easy. I know there's not really $100,000 houses out there. Forgive me. Blame the boomers. All right, what's the down payment? So what do you want to try first? Do you want to try the 20% down payment first? Do you want to try the 10% in the credit score first? Or do you want to try and not get a mortgage first? What should we try first? We got to try everything. Not get the mortgage. Okay, so we need less than a 10% down payment, and then the credit score less than 800, right? So if we have less than 10% and our credit score is less than 800, it should tell us no. Because if our credit score is 800, more than 800, we get yes. If our down payment's more than 20%, we get yes. Or if it's 10% or more and we have 700 more, we get yes. So let's say we just have $5,000, and we could have $799 for a credit score. We don't qualify, right? Because the down payment was not high enough to match with our credit score of more than 700. So did what we expected so far. Let's try it again. Sure, some cost. All right, house do we want to buy? 100,000. Let's do a yes. So do you want to do by credit score or by down payment? Which one do we want to get a yes with? I'm sorry? Down payment. Okay, so let's do 20%. So 20,000. And then should not matter what the credit score is. So let's say 0, right? Because the rule is if you can put 20% more down, we just say yes. We don't care what your credit score is because we've got your money. You can get the mortgage, right? This seems to be working so far. So it seems like this one works, right? We checked this one. Now let's try a credit score of more than 800 here. Let's run it again. So $100,000 house. So down payment, let's say $0 down, but we have more than 800 credit score. Like 801 should say we get the mortgage, right? Because this one is true. Nothing else matters because it's this or this or this, right? If any one of them in a big or, this or 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 this, if any one of those is true, the whole thing is true. When you go to Wendy's and they say, do you want to order something off the menu? Anything on that menu, this or 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 this, if that's true, you're going to order something at Wendy's, right? The baked potatoes are pretty decent, right? Sure. All right, so that one's good. So let's also then try this last one. This is where we're probably going to run into trouble here because sometimes this is tricky. So we want less than 20%, more than 10%, right? We want less than 800, but more than 700 because I want to make sure it qualifies in this and this being true, makes the whole thing true. Okay, so let's try it. So let's say $100,000 house, down payment, let's do 10% exactly, so 10,000. Credit score of, we'll say 700 exactly. We get the mortgage because it was 10% or more, and we were at 700 or more. This and this were true. It doesn't matter that this was false or this was false because or this was true, right? False or true. There's a true in there. The whole thing's true.
How much was your down payment this time?
That was exactly 10%. 10,000 here, because it should matter for greater than or equal to 10%.
And what was your credit score?
700. To catch our credit score of greater than or equal to 700.
Okay.
Sweet. So this gets a little messy here. A little hard to follow, right? There's nothing wrong with it. This will work. Another approach we can use is you can have more than one if here. You can have a chain of if, else 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 if, as many as you want here, conditions. Sometimes that works out prettier. So we're going to do all of this again here, just in a different form. So I want the first part here, that's fine, and then I'll cut out the rest. We'll come back to this in a minute. Let me say, okay, if this one is true here, right? This was our rule. If you had 20% or more down payment, we're just going to give you the mortgage. That's our rule. Now I'm going to add another case. So if else, we are mutually exclusive. We can throw another if in there. So I can say if, else if, something else. Set of curly braces. It gets a little nuts here, but that's okay. You can follow along. So if this one is true, this one will run. If it's not true, the else runs. The else says, okay, is this one true? If this one's true, this if block runs. If that one's not true, now we get to the else. So in this case, we have the rest of this, our credit score more than 800 here. Again, I'm going to cut some of that out here real quick. Let's see how well this works. So now I have the same code in here twice. I'm going to feel a little bad about myself, but this is not too bad because it's more easily readable here. So, sometimes we make those decisions and we say, it looks nicer this way. I don't care that I had to type more because it's prettier. And, prettier code is actually very valuable. You want to be able to read your code and understand what it's doing. It'll save you a lot of time, I promise. So we're saying, okay, if this is true, you get the mortgage. If it's not true, else. Okay, what's the else? Well, the else says, if this is true, you get the mortgage. If that's not true, else. And in this case, we have one more else if here. We said else if. And our last check here then, let's see. There we go. So the last check, now this is getting a little bit long in the line, but that's okay. I'm zoomed in kind of far here. Right? You should be fine on one line. If you want, bring it down. Java doesn't care about the white space, right? You could have these all on separate lines. I don't recommend this. This is perfectly legal Java code. If you do this, I'm going to be real upset with you, right? It works. You'll get the points, but I'll be upset with you, okay? Because me reading it is just, it's painful, right? Please, right? Do better, okay? Again, it'll work. It's okay. So I'll just reformat code. Oh, it didn't even fix it. Gross. Okay. It must think we really like those lines. So this and this if you want. This all on one line if you want. Doesn't really matter. I generally like, if we're anding or oring, to have them on separate lines. I just like it, right? I think that's easy. So this is one group, and this is one group, and we could have another and, we could have another and, we could have another or. That's fine. Anyway, we want to organize. That's okay. Now, if this is true, this block of code runs. If the if block runs, what happens to the else block? It gets skipped. So everything else gets skipped. So an if, else 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 chain is still mutually exclusive. One and only one of those will run because we've locked them all together. We've chained them all together in one big this or this or this or this or this or this or this. We have a nice big group here. So in this case, hey, you can get the mortgage. Okay. If that's not true, then, right? So that means this is not true, this is not true, this is not true. Then we finally get our else here, saying, okay, you don't qualify. Sorry, too bad. Keep paying rent, and we'll pretend like that never happened because we don't count towards your credit score. I don't make the rules. I'm sorry. All right. So this does exactly what this does. But which one's prettier? Do you have a preference? I mean, we could make this maybe a little bit nicer if we said each of these was its own line, right? And try and line these up or something, or like this one, or this one, or this one. Like it's kind of close. It's not too bad here, but it does the exact same thing. Well, we should probably test it, make sure it does what it's supposed to do. But I feel pretty confident it'll do what it's supposed to do. We could test it and see, make sure we get the mortgage twice, right? But either way, it gets the exact same job done, right? It's just a different style. You can put it all in one if because it's the exact same result every time, or have 3 different ifs with the exact same result 3 times. Okay, right? It does functionally the same thing. We're saying, okay, this qualifies you, or this qualifies you, or this qualifies you.
Can you pause for 2 seconds?
This one?
Yep, thank you.
So this is taking a Boolean expression or Boolean valued expression and doing Boolean operations on it. You got a question?
Yeah. So you start with the first version,
Uh-huh. This one here?
and then you come up with like another, give you another, hey, this.
Mhm.
Now they can get one. You just add in, I'll say underneath it right in the middle there or something,
In this one? Sure. Yeah, we can have another else if.
and then add in a new criteria, like whatever it might be, like, oh, you have 50% and 200 for you. I'll give you more.
Sure. House price greater than or equal to 0.5.
So that's something like you could do like later on.
Yep.
Back in your code and update it.
Yeah. Yeah, you can mix and match, right? You can have most of it here and then another else if and then an else. You can have them all be separate if, else if, else if. It'll all work. It's just a style preference at this point. So you're going to see people do it differently, right? It all works. Generally, you don't want to mix and match. I wouldn't recommend this approach, right? If you're going to do it all in one, do it all in one. If you want to do them all separate, do them all separate. Just whatever style you pick, stick with it. You want to be consistent, at least in your code here. And again, every organization will have their own style guidelines for this is how we want everyone to do it. Because if everyone does it the same way, it just reads faster when you're looking at someone else's code and you come back to it to go make changes later. This is why we have conventions that people follow. Yeah?
Like in the first example, you better off just put another or.
Yeah, I would just put another or, oops. Yeah, add something in here, right? With the right parentheses in here somewhere. Yeah, so that would be my preferred approach to add to the first one rather than mixing and matching your if else if here. And you can have as many of these as you want, right? You could have 50 different, and I'm sure some banks have ridiculous sets of rules here. I don't know, like some of them ask how much money you have in your checking account. Sure, I don't make up the rules. Some of them just look at credit scores because that's all they care about, and they just rubber stamp stuff. So, you know, the industry is they make their own rules, I guess. So, and this is why stuff like software is useful for businesses, because if you can save someone's time instead of them having to look at a bunch of papers and fill out a spreadsheet or do a bunch of calculations here, be like, hey, plug in a bunch of numbers and the system tells you yes or no. That's kind of cool, right? Yeah, this is really easy for me now. I just plug stuff in and the computer tells me yes or no, you get it or not. I don't really have to do anything on my part other than type numbers in. It's cool. The downside of that, just as a, how the system works, if banks aren't doing actual underwriting for mortgages and they're not actually looking at your finances and the only thing they look at is a credit score, turns out bad stuff happens because credit scores aren't a really good measure of people. Who knew, right? We can't boil people down to numbers. Like, it's a weird system. We know it's a weird system. We know, like, well, if you make your rent payment on time for 5 years in a row and your rent payment was $1,500 and your mortgage was going to be $1,500, you can probably pay $1,500 a month, and the bank says no anyway because they're stupid. Like, software is not the solution for everything, but you can see why companies want software to make things faster for them because they don't like paying money to people. So anyway, this is some if, else if stuff here. So another fun thing we can do that's pretty similar here. We can say, let's take a grade percentage and turn it into a letter. So a pretty quick example. So I'll say, hey, tell me what your score is, like 1 to 100. What's your percentage score here? So we'll ask them your score 1 to 100. Now, anytime you're asking the user to enter something, I'm a big fan of telling them what you expect. Like if I just say enter your score, do you want 0.95 because that's technically 95%? Do you want the number 95, which is really 9,500%? Like, tell me what you want here so I know what to type in. So giving them more is always good because pretend your users are stupid. Well, people do the weirdest things to computers because they just aren't really paying a lot of attention. The less mental load they have, the better it is for them. Right? Make it easy for users. That part I know about user experience. So we'll get an integer then. Right? I'm expecting an integer, not expecting a decimal place because I said 1 to 100 here. So my score then can equal integer.parseInt of the keyboard next line. Again, couple letters tab, couple letters tab, couple letters tab. You don't have to type it all. Sure, it'll come. It's okay. So now we'll have a bunch of if, else 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 if here, right? Because you have an A plus, you have an A minus, or you have an A plus, you have an A, you have an A minus, you have a B plus, you have a B, you have a B minus, on and on and on. Sure, let's go for it. So if your score then is greater than or equal to, what do we say, 97, I think gives you an A plus or something. Is that in here? I feel like that's in here somewhere. We don't have an A plus? We not have an A plus? That's sad. All right, I'm sorry. We just have an A. I lied. All right, so if it's greater than or equal to 94, A, right? 94 or higher, you get an A. If it's not 94 or higher, right? Else if my score is greater than or equal to 90, A minus, right? If it's not greater than 94 and it's not greater than 90, all right, well, how about if score is greater than or equal to, was it 87? 86. Wow. All right, this is embarrassing. This is why it's written down here. That's okay. That's a B plus. right? Then is it 94, 84, or 83? Okay, so now it's 83. Why is it 94 and 83? These numbers don't match. I didn't make this up. They gave it to me. I'm sorry. And I'm super confused now, but 83. Okay, sure. So else if my score is greater than or equal to 83, that's just a B. B's are okay, by the way. Don't let B's make you feel bad here. B's a passing grade. If score is greater than or equal to 80, greater than or equal to 80, that's a B minus. Right? Now we got a couple more to go. I'm just going to copy paste here because I'm lazy. And now we get C plus, C, and C minus for 76, 73, and 70. Right? I think those are the right numbers. 76, 73, 70. Then we have a D plus and a D. Sure. So two more then. Not that last one here. So then D plus is 66 and 63 is a D. If it's not an A, it's not an A minus, not a B. You good? Oh, all right. Else, it's an F. Right? There is no D minus on this scale here. So there's a bunch of different if, else if, else ifs, else ifs, else ifs, else ifs, else ifs, else ifs, as many as we need here. Perfectly fine. They're chained together. They're mutually exclusive. One and only one of these will run. Yeah. We're going to do that next. Yes, thank you. We're going to do that in just a second. Yep. Yeah. So the reason these are mutually exclusive, right? Someone just asked if we just use ifs. We can just use ifs. I'll show you that in just 1 second. Is that if your score is 100, it's more than 94, it's more than 90, it's more than 86, it's more than 83, it's more than 80, it's more than all of these would be true. You don't want all of those to run if your score is 100, right? You want it to stop at the A and not give you another letter. So if you don't like writing else's, that's okay. We have options here. So I'm going to copy paste all of this here. We'll do it again, and we're going to get rid of all the else's. So if they're not attached, they probably should be on separate lines here. It'll make life easier for us. And then we need to fix this to make the logic better so that it only runs if it's correct. So this last one here, we don't want if else, because you don't want a D or an F to be your only two options, right? So we're going this last one is no longer an else here, it's also an if. We have to figure out what goes in here in a second. Okay. But now if I want only one of these to run here, I need to add some additional logic. So more than 94, still an A grade. That's all it is. 94, 95, 96, 97, 98, 99, 100. If someone gives you extra credit, you're at 101, still an A. There's no A pluses here, sorry. Sure, right? But now I don't want it to tell you you get an A minus if your score is 84 or more. So I need to add this condition here and do some more logic. So I'm going to say, okay, if your score is less than 94 and it's more than 90, right? Now, if your score is more than or equal to 94, this is disqualified because this will be false. Anything false and whatever, the whole thing is false, this won't tell you you have an A minus because your score is not less than 94. Right? This is good. We want it to stop at an A, not give you an A minus if your score is 94, 95, 96, 95, whatever here. So we have to add additional checks here all along the board, and that's okay. So less than 90, so less than 90 and more than or greater than or equal to 86. So that's 86, 87, 88, 89, right? Would fit in here, right? Less than 86 and more than 83. Less than 83 and more than 80, right? Less than 80 and more than 76. Less than 76 and more than 73. Less than 73 and more than 70. You can see it works. I have to do a lot of typing here, but sure, this is fine. No problem here. This will get the job done. And then this is less than 66 and more than 63. So this last one here then is scores less than 63, right? If I'm 63 or higher, we get the D. If or less than 63, I need the else. So each of these now is an if statement. Now, while this works and does the same thing functionally, this is technically slower. Because remember, we said if you have a chain of these if, else if, else if, else if, they're mutually exclusive. As soon as one of them runs, Java says, oh, this one ran, I can skip the rest. Java doesn't look at anything else here. What happens if they're all ifs here is Java looks at every single one of these, even though we know it won't be true. Like if you have an A, it still has to go and do the arithmetic and say, okay, is it this? No, that's false. Is it this? No, that's false. Is it this? No, it's false. Is it this? No, it's false. Now we're not going to notice that it's slow because it can do 15 operations faster than we can blink. But if we had to do this thousands of times, like if I'm running, transcripts at the end of the semester for all 12,000, 15,000 students, whatever the number is nowadays, right? And I have to do 10 extra operations per student, that'll add up to, a couple seconds. Again, no one's really going to notice, but it is slower. So this one feels bad if we want to look at the particular science of how fast things are fast. For what we care about, it gets the job done. That's fine. We get our points. Right? This is our very first coding class. We don't care about fast. Right? That's a thing you worry about later once you're familiar with coding.
So else if is generally better.
Yeah. If they're mutually exclusive, else if is better. Now, you can't have more than one letter, so we know these are mutually exclusive. Else if is better.
Mutually exclusive, you said?
Yep. Then our else if is going to be better because it'll be ever so slightly faster for our purposes. Not a whole lot faster. We don't care. But again, it's probably also nicer because you don't have to have all of these in here. And the more times you have to type numbers in, I don't know about you, but I type the wrong keys all the time. You've seen me do it. I'm more likely to have a bug in my code here because I had to type a bunch of numbers more than once now, right? I have 73 and 73. I have 70 and 70. I have 66 and 60. Like, oops. If I mistyped one of these here, I'm going to give someone the wrong letter. Bad news bears, right? Someone will be either happy with me or upset with me. Maybe it's good if I did it, in your favor. If I did it the wrong way. I misscored someone once because they changed numbers on me. Like it was 94 and then 86 and 83, and I thought it was like a minus instead of a plus, and they didn't yell at me, but they were unhappy with me. I'm like, I'm sorry, I screwed up, and I went and changed it, but I had to do a bunch of paperwork, and I was really sad that I had to do paperwork because I hate paperwork. Like I'm allergic to it or something. It's just awful. I don't know. So either way is perfectly fine, right? It's okay. We have options here. Okay.
You need to post all this online.
Yeah, let's do it right now. So if else if, else if. Yeah, it's all recorded too, and it's in the book. Yep. So how far do we get in the book here? Let's see. This is, so we're kind of jumping around here. I'm sorry, the chapter is not in the way I would like to do it. Again, I haven't had a chance to rewrite it yet. So this is like section 5 for if statements here. Let's put this in here. So this is section 5, all over ifs here.
Chapter 3 for the next 2 weeks.
Yep. Chapter 3, section 5 here. So like this is all about the ifs. So if some Boolean expression, right, something that gives you a true or false has to go in here. You can't put anything else, right? Otherwise it's going to yell at you. So if you try and do something that's not a Boolean expression, if you say like if 10 plus 10, it's going to yell at you and say required type Boolean found in int. You've got to put something that will give you a Boolean eventually here. Now, you can also put if true. True is the literal value of true. If you do this, though, you don't need the if because you know it's going to run because it's already true, right? So that's not all that useful. But sometimes it's nice to have a Boolean like, are you tired equals, this is true. And then I can say, hey, if are you tired, do some code here. Now, probably this value will change somewhere in here, and I can ask, like we can ask the user, hey, if you're tired, enter a Y. Right? We can do that. So we can say, if you are tired, enter Y. Single quotes or something. You could escape the back double quotes, that's fine. So hopefully they'll enter the letter Y here. And then you can use characters. I don't recommend it because it's more complex here. We can do a string for tired or not. Tired input, sure, tired input. is my keyboard.next line. Now this is perfect. We're gonna segue into strings. Now I mentioned integers are great for greater than, less than, equal to. Strings are not. Right? It just doesn't work like that because strings are a whole different animal in Java. So to see if a string equals something, we have to do a special thing. So I'm going to say, hey, if tired input. Now I don't want to say equals y here. So this is do not do this. It won't work. Won't work. This is no good here. What we have to do instead, again, this doesn't work. Sure. You have to say if my tired input dot equals, and you have two options here. You can say equals, or my almost always preferred equals ignore case, which guess what that does for you? Yeah, it ignores the casing. Uppercase, lowercase, sure, they're the same. Because remember how characters are stored as numbers? Capital A is 65. The lowercase a is not 65. So if you ask Java, hey, does capital A equal lowercase a? It says no, because the numbers don't match. Even when we're talking about strings. So equals ignore case will say, sure, I don't care if it's uppercase or lowercase, I will compare it for you. So I say, hey, if it equals a y here, then I can do something silly like, are you tired equals true. Sure, and then later I can say, hey, if you're tired. Now, again, this is kind of silly because I already know it's true. I could just do it in this block here. I don't need to have another Boolean, but sometimes it's nice to have a Boolean value for a true or false that you can use in your code. And sure, it's another type. You'll use Booleans often enough. Not as often as we'll use integers and strings and doubles, but we'll use them. They have fun purposes where you can say this is true or false. So while the book says you need a Boolean expression, you just need a Boolean. Something that's true or false, whether or not that's an expression or a value that's already true or false. Either of those is fine, right? Yeah, I'll post a quiz for this after. So another fun thing you can do is you can put an if inside of an if here. This gets awkward, and this is why I always recommend your curly braces, because this is just gross, right? Just don't do that. So you want ifs with curly braces. I don't like how he skips them here. He upsets me, but that's okay. It's fine. One of these days I'll go fix it. So you can have ifs inside of other ifs, or ifs inside of other elses, right? You can go nuts here. Now, at some point, you're going to be tabbed in and tabbed in and tabbed in and tabbed in and tabbed in so far that you can't see your code. It's probably no good. And there are other things we just don't know what those things are yet. So don't worry too much about it. We probably won't have lots of ifs inside of ifs inside of ifs inside of ifs. You generally don't need to, so won't be too bad. Got a question?
Yeah, I have a stupid question. On your code, so if you get the scholarship, does it ask you for the price of the house?
So regardless of the scholarship here up above, everything else runs. So the only part that is this will run or this will run is, so it's all based on your curly braces. So wherever the ending curly brace is, so like when you click on it, it'll highlight the matching one. It'll say that block of code will run. So yeah, if you're not careful with your curly braces, if all of this is inside my code, now I don't even know where that matching one is right now. It doesn't even tell me. I got to scroll way down here to see. Well, look, here's the matching one for that else. Now, if you touch a closing one, it'll highlight the opening one. I don't know why it doesn't do it in reverse, but so I click on a closing curly brace and it says, oh, hey, by the way, up at line 13, here's your start. Here's where you match. So you get some visual cues. The tool is really nice for this, that sort of thing. So yeah, you got to be careful with these, and that's why it's important to make sure everything lines up. That's why we like the tabs. So when things are tabbed in inside of a code block, inside of these curly braces, it's that visual cue that, oh, hey, it all belongs to this if, or this else, or this else if, or this else if. Yep. Yeah, so it's a visual cue for programmers to see, oh, okay, I know you belong here. Right? I mean, I could grab all of it here and shift tab it in here. This is legal Java code. Don't do this, please. This is awful. No one wants to read this, right? This is real ugly. So just don't do that. So I'll just go back and format. Right? The format option is my favorite. It's really nice. Oh, it didn't fix my comments though. So if you grab more than one line, you can tab or shift tab more than one line at a time. That's how I'm doing that. Shift tab to bring it back, tab to tab it in. All sorts of cool shortcuts. I'm sorry. I try and call them out as I use them, but sometimes it doesn't work right. Oh, I gotta fix those ones now. Goodness gracious. Oops. Ooh, that one broke. Doesn't work. So you can't use equals with strings. Okay. So if you're tired, we can say break time. So we'll ask them, if you're tired, enter a Y. Eventually, this code will run, right? Because it's still going top to bottom, but it's going to start branching here. So one of the cool things we can do is, let me stop this here. We can run our code in debug mode. Debug mode is going to be your favorite thing about IntelliJ, or any good IDE has a debug mode. What it does is it tells Java to stop and wait. So it will pause it anywhere we tell it to pause. So to make it pause somewhere, you put something in known as a breakpoint. So notice I have all these line numbers and then there's a bunch of gray space that's wasted here. Well, that wasted space is where we put a breakpoint in. So I'm going to come down to, say, line 10 and click in this gray space and get a big fat red dot. That's a breakpoint. Okay. When it gets to line 10, it will pause for me if I run it in debug mode. Now, the main run button here just runs it, ignores your breakpoints. To get it to pause when you get to a breakpoint, you got to use the little bug icon. We are debugging. We call it debug because we use this to hopefully find the bugs in our code and see what's not working right. So in debug mode, what's really cool is it shows you the value of every variable. Sure, allow access. That's weird. Why not? All right. So I'm not to line 10 yet. That's okay. So it says enter your cost, right? Enter your code. You can see what it says. So I will enter a number here. Now it gets to line 10 and it's paused. So I get a new screen here. Now you kind of run out of screen space pretty quick, but maybe you can pull things up, pull things down, kind of work your way through however you want here. So it says, hey, these are all of your variables. You've got this thing you called keyboard. It's a scanner at 937. That doesn't really mean anything. It's garbage for us. That's fine. You have args. We don't know what that is. That's okay. But you have total cost. It says total cost is 1,000. It's a little small, hard to see. On your screen, it might be a little easier here, which is fun. So in debug mode, I can see the value of my variables. And then I have some new buttons I can click. I have a step over, a step into, and usually I ignore this red one here, and a step out. So step over runs the line that we're on. Step into will go into something if we're on a line that's got some curly braces, essentially. And step out will step out. We'll use this one more later. We'll get to step out later. So most of the time I just step over. I'll say, okay, step over. This line of code ran. The next thing Java's doing is running line 14. So we know this was not true because it didn't go into line 11. And I can see, hey, 1,000 is not more than or equal to 5,000. It shouldn't have gone in there. So this is doing what I expect. And I'll see, okay, now it's about to print this. So if I step over, it printed. Now the problem is I don't see the output because we only have so much screen space. We have the debugger tab, we have the console tab. I can flip back and forth, debugger, console, debugger, console, yada, 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 back and forth to see the output. So we see it did run line 14. It's still waiting to run line 17. It's waiting for me to tell it, okay, Java, you can do the next thing here. So I can run it, I can run it, I can run it, and now it's sitting and waiting. So it looks like it's not doing anything because we hit a keyboard next line. I don't see what's happening here because it's waiting for more input. This little blinky cursor here, waiting for me to say, what's the price of the house? Give it a value here. Now it comes back to debug mode, and I can step again, step again. All right, what's my down payment? 10,000, step again. Credit score, 100. Okay, so now we're at line 34. If I can flip back to debugger, I can see, hey, here's the house price, here's the down payment, here's the credit score. I can go and change the values too. While it's running, I can change what Java is storing. So I right-clicked and said set value. I can go change these numbers mid-run. That's if you really want to mess with it. I mean, a lot of this is going to come from user input, so it shouldn't really matter. But okay, if the credit score is 900, this should be true, right? So if we step, we get, okay, I'm into the, if this was true, this is what we expect to have happen. This was true, it'll tell me I got the mortgage. Now when I step, right, is the down payment more than 20%? this should not be true, right? We said the down payment was 10% of $10,000. Here, this won't be true. So the next thing it's going to run is the next else if. Okay, hey, is the credit score more than 800? And Java's even telling me here, IntelliJ is saying, hey, this is true, by the way. I know it's going to be true. It's showing me here in the code, yes, this is true. So you can see as we're running it in debug mode, we can see line by line by line what's happening, what the values are, and we can kind of follow the logic a little bit nicer than, hey, let me try it, let me try it, let me try it, let me try it, and I have to run it 10 times with 10 different values. We can step and we say, okay, we get the mortgage. Right, now we enter a score, 1 to 99. What's our score here? Everyone wants 100%, right? Go for it. So, hey, a score is greater than or equal to 94, true. Step, okay, now we get an A. Now a score greater than or equal to 94, this one's true, we get an A. But now as we step, we'll see it goes to each if, and it's telling me, hey, this is false. This one's false, this one's false, this one's false, this one's false, this one. So we said, this is a little bit slower, still gets the job done, it's okay, it's slower. It'll work here. Finally, we'll get to this, are you tired or not? So, are you tired? Why? Yes, we're tired. All right, if the tired input equals y, it didn't work, right? That you can't use that double equals operator. It just doesn't work with strings. There's reasons we'll get to in a couple chapters. Now we'll say, hey, does the tired input equals ignore case, quote y? This is how you compare strings. You use equals ignore case. This one's true, by the way. We'll set the are you tired value to true, yay. And then if are you tired is true, we'll say it's break time. Then we get break time. There's nothing else. I hit the last curly brace. I'm done. It finished debugging. So we can kind of watch it run as we go. Why don't we take a break, take 10 more minutes. Sorry, that took a little longer than I wanted to. But we'll come back in 10. I'll pick it up from there.
in container. And let's just say one day I accidentally did not mute my mic and I was like, fucking cock, fucking motherfucker.
Sure, that went over very well.
He asked me who I was talking to, and I was like, oh, it's Tina.
My dog knocked something over.
That's not my opinion of you at all. Christy, I really enjoy your sarcasm. Thank you.
All right, so we're mostly through section 5. Kind of jumping around here a little bit. It's okay. All of chapter 3 is big. We'll get to all the other stuff in a little bit. Someone had asked about drawing pictures, this idea of a flow chart. I'm not much of an artiste. I don't draw them very well, but this sort of idea is a nice way to visualize or get your ideas out when we're trying to figure out how to solve a problem. So if you can draw a picture of it, you're much more likely to be able to turn it into Java code, right? I tend to just say, I want to explain it in English. Here's step by step by step by step. I'll turn it into Java code. I've got the advantage of having been doing this for 15 years. So pictures are great. I don't mean to knock the pictures at all. I just don't draw them well. So if we're thinking of a chain of if, else if, else if, else if, else if statements here, we're going to say, okay, is the first statement true? If it is, then statement 1 runs, and then the program keeps going. If it's not true, is the second else if block true? If it is, then the second thing happens, and then we keep going. As many of these chained as we have, you can see they're mutually exclusive. One of these statements will run, right, and only one, because that's the way that we wrote that. You can think of if, else if as this idea of a flowchart. Great way to do things. There's a whole set of tools you'll use called unified modeling language, ways of drawing diagrams for explaining the flow of code, the design of code. It's fantastic. Learn all about it in systems analysis and design and software engineering. We just don't really have time to talk about it, because we have so much to cover. The pictures are great. I don't mean to knock them at all. They're fantastic. He's got lots of other examples here. I think X, Y, and Z is just, these sort of examples confuse me because I don't do well with X, Y's, and Z's, but that's okay. So if X is less than Y and X is less than Z, then X must be the smallest. Sure. And then maybe Y or maybe Z. I don't know. If X is more than Y and X is more than Z, well, then X must be the biggest, right? So X or Y first and then X. Otherwise, X must be between them because it's not smaller than both and it's not bigger than both, right? So it's a weird way to explain it, but sure, he's got some examples out here. Other fun things you can do, right? This idea of, this is like English version here, right, of what we're going to do. He's getting it step by step by step. Now, it looks kind of like code. It's close to code, but it's not functional Java code. It's pseudo code. It's almost code. It's step by step by step and looks codish here. This is a great way of seeing if I can solve the problem in pseudocode, if I can solve it in English, then I'll go translate it to Java. A lot of folks love jumping right into writing Java code before they actually know how to solve the problem, what each step is. That's the best way to get yourself pissed off at Eric. Like, I give you an assignment and you just start writing Java code and you don't actually know all the steps in English, you're just going to get mad at me. And it's okay, I can take it. I got a pretty thick skin. That's okay, but you're going to get frustrated, you're going to bang your head against the wall, and you're going to think coding is awful. And I don't want you to feel like that, because I think you can do it, but we want to take the right approach. So get your steps down first. What do I need to do step by step by step by step in English? And then you can even take this idea, we call this a model, right? This is a model of my solution here. We can pretend that we're running it. Like we use the debugger and we said, okay, run this line and run this line and run this line and run this line. We can check our model in English. We'll say, okay, sure, let's get a double here. Again, the text.io stuff, don't worry about. I think Scanner's easier. He disagrees with me. I didn't write a website book, so he gets to use his stuff. That's fine. I'll go change it later. So, okay, get a double. That's called our measurement. Get units. That's a word, a string. Sure. If the units is inches, or if units are inches, I guess that's proper English. Sure. Then inches is the measurement. If it's not inches, if the units is feet, then my measurement times 12. Right? Because I gave you a number of feet, and I'm going to turn feet into inches. Because the American system of measurement, or the imperial system of measurement, is awful. There are 12 inches in a foot, because that makes no sense at all. Why can't we have the metric system where we have base 10 and 100 centimeters in a meter? Because life is easy that way. But sure. And then we have yards. There are 36 inches in a yard, because yes, why not? And there are 5,280 feet in a mile. Sure, so 5,280 feet times 12 inches will tell me how many inches are in the miles that you gave me. If it's not inches, it's not feet, it's not yards, it's not miles, we tell them you're illegal. Oh my goodness, this is awful. Like, learn the metric system, friend. It's not illegal to use metric. And then print an error message and stop, sure. And then we'll say, okay, feet is the inches divided by 12, yards is the inches divided by 36, miles is inches divided by this, and figure out the results. We'll tell you how many feet, how many inches, how many miles that you told me. So here's an English version, or kind of code-ish, kind of English, pseudocode. Right? We've got down every step of what we're going to do to say, hey, how do I ask them to enter a number and tell me what the unit was and figure out how many inches it is? Okay. Then we can go and turn this into code here. And he's got his nice little code example. So we'll go get some values here. Don't worry about the loop. We'll come back to that later. But hey, okay, if you give me inches or inches or inch, this is a nice friendly way of saying I'll let the user type anything they want in here and I'll try and figure it out. This is friendly, right? I might suggest you tell them in your prompt, enter inch, feet, mile, something, right? I mean, and hopefully you'll get better input. This is a little annoying to have to do all of this, but that's fine. You know, it works. Foot versus feet versus ft. Sure. Those are all ways of saying this. That's okay. Yard, yard. Sure. Mile, miles, my. Okay. Sorry, but I don't understand your units. That's nice, right? Then convert them all out, spit it all back out. This formatted stuff, we skipped over most of this. It's a placeholder. We're substituting things. Don't worry too much about it here. It makes it pretty. That's okay. It's spitting out every single equivalency here. So it's that many inches, that many feet, that many miles, right, for whatever you enter here. So this gives you a certain number of decimal places and padding. So it'll always be a fixed size. It makes the output look really pretty. I don't care too much about pretty. So we you know, you can go read the chapter on it. That's fine. So that's his converter. So if you start with step by step in English, you'll have a much better time translating it to code. Right? If we just said, hey, write something that reads their input, converts, and then good luck. You know, as of right now at 8:30 on a Tuesday, we've been talking about it for a little while. It might not go so well. Is that fair to say? Okay. So spend the time thinking about what we're going to do step by step by step. I promised I was going to show you the video. I probably can't show it because I'm streaming. There's a funny YouTube video where they go and ask a kid how to make a peanut butter and jelly sandwich, and then they follow the directions literally. Did I tell you about that? So if you say put the peanut butter on the bread, you just put the jar on the bread. You don't open it or anything. You try and take a bite of a peanut butter jar, and the kid laughs hysterically. My kids thought it was funny the first time. When I did it again, they weren't impressed. That's fine. So think about what we're doing when we go design our solutions here. You can have an empty statement. I don't think this is useful here. What you want to be careful of is extra semicolons. It's not bad at all. It's not going to do anything here. Like, it'll work. Where you're going to run into trouble is if you put a semicolon in the bad spot here. So if you say, are you tired, semicolon, here. This is legal Java code. And because Java says you don't need curly braces, it says, okay, if this is true, this was your one line of code you got. Great, it ran. This block of code now will always run no matter what. And it's going to drive you crazy, and you're going to have a bug in your program because this will always run even if this is true or false. It doesn't matter what the value of this is because it's no longer attached to the if because we put a semicolon here. So you got to be careful with them. At the end over here, Java doesn't care. It even grays it out here, and IntelliJ says, hey, it's unnecessary. This is wrong, but now not unnecessary because it's doing what we told it to do. It's ending the if. If this is true, nothing, empty. Then this will run. So just be careful with your semicolons where you put them here. And then again, we'll get to for loops after. Okay, so that's ifs and elses. Ifs inside of ifs inside of elses, if, else, if chains, all sorts of things we can do to make specific things happen based on if something's true or false. Everything has to boil down to a true or false. Right? If you can't get it down to a single true or false value, we can't make an if out of it. Right? It can be complex. You can have an and an or and an and an or and an and an or and greater thans and less thans and anything you want here. But all of that eventually will boil down to a single true or false. to decide whether or not that code runs or not. Okay. Switches are not really a shorthand, another way of writing a bunch of if, else, if, else, if, else, if. I don't like switches. I try to never use them because they bother me. I have my own problems. That's okay. We'll talk about them. If you want to use them, great. If you don't want to use them, great. I don't care. I mean, it does the exact same job as an if, else, if, else, if, else, if. It's just funny looking, and that's why I don't like it. So that's all it is. So the idea with a switch is we say switch some value, and then I give it cases and statements. It's a really weird way to write the code, very different than what we've looked at so far. So they'll say, okay, switch on n. If n is 1, case 1, if n equals 1, do this. If n equals 2 or 4 or 8, do this. If n equals 3 or 6 or 9, do this. If n equals 5, do this. If none of these are true, do the default thing. This is really weird looking code. I don't like it. That's really the entire reason I don't use switches, because I just don't like it. It's very different looking. So this is the exact same result with if, else, if, else, if. So if n is 1, do this. If n is 2 or n is 4 or n is 8, do this. If n is 3 or n is 6 or n is 9, right? We're ORing these together. If this one is true or this one is true or this one is true, then this block of code runs. Or if n is 5, this block of code runs. Or this last else here, this block of code runs. Okay? Exact same output here. Some people love switches. Go for it. If you love them, go for it. I won't stop you here. It's okay. I just don't like them. That's entirely me here. So that's his switches. Enums, default. Yeah, these are fine. The other format. So this is the newer format in, I forget, one of the later versions of Java. They switched to this where you can use this arrow syntax. It's weird. We don't use it lots of other places. It's newer because it saves you a line of code. So this is relatively short and concise. Not too bad if we like spend a bunch of time and think about what it means here. The other way we would have written that, the older style, is switch with cases, and then you have statements, and use the break keyword to say, break this case, stop the case. I don't like these either. So he says, okay, if the case is 1, print the numbers 1 and break. As soon as we see a break, the switch stops. With this syntax, you list each of your cases as a separate line. So if 2 is true, or 4 is true, or 8 is true, these will run and then break. If 3, 6, or 9 is true, run these and then break. If 5 is true, run these and break. Default. Now there's no break at default. You could have one if you want, but at the end of the default, it's already at the end of the switch. There's really nothing to break, nothing to end at that point because you're already at the end. So you usually don't have a break with your defaults because you're at the end. So these are weird, and it's specific matches on exact values. So you don't have this idea of a range here. So if I wanted to do my grade output here, right, it's not going to be as pretty here. I could do it, and we'll do it here just for fun because I'll give you that fun illustration here. So we're going to say, okay, instead of if score is this, we're going to say switch on the score. So switch on score. Then we get a set of curly braces here. And everything inside the set of curly braces now belongs to my switch. Right? Kind of like an if. So this block of code runs when this switch runs here. So we can say, hey, case 100, case 99, case 98, case 97, case 96, case 95, case 94, a break. You can see where this is going. This is no fun, right? Because you are doing exact matches here. Yeah, right? So anything that is a switch, you can write as an if, else, if, else, if, else, if. Not anything that's an if, else, if, else, if, else, if we can write as a switch, because there is no way for me to do this in my switch here without enumerating every single possible value here. So, okay, this one, sure, from 0 to 100, we could do that. Now, if I'm going to say, hey, enter a number between like 0 and a million, and then do something, you're not writing a million lines of code for your switch. Just don't, right? So it's fair to say not every if, else if can be written as a switch. But every switch you can write as an if, else if you want, right? So this is why switches are ugly. Ugly. Eric is scared of them. Sure. That's fine. And let me format this real quick. There. On and on and on. Keep on going, right, with the next set of cases. And nope. There we go. I wanted that tabbed in. You could keep on going. So that switches. You'll see them. People love them. Sure, that's fine. I don't love them, but know they exist. It's a funny syntax, but you can figure out going and reading it, figuring it out here. But that's ifs, else's, and switches. This is ways to control what happens in my code if certain things are true, or if they're not true. Right? Based on a condition, I do this or I do this. Now, the very first example we had was just an if, you got a discount. You don't have to have the else. It's totally optional. It just depends on whatever your code is. So I can say, hey, if student went to tutoring, grade plus equals 1. That's fine. There is no else there, right? That's the case. If you went to tutoring, you get an extra point. Go for it. So what we put in our code is completely dependent on what we're trying to solve, what the problem we're trying to solve is. Right? So for our lab, we're going to do a quick little example and see if we have enough pizza to serve at our party. Because you don't want to have a party faux pas and run out of pizza. That's just real bad here. We got to make sure we have enough pizza. Okay? So we'll make sure we have enough pizza for our friends. So let me go make a new lab for you here. Give me a second. 3, this is lab 2. So this will be hopefully shorter than last week's lab, hopefully. And then we also have to talk about the project as well. So we'll have the lab, we'll talk about the project. Ideally, you get the lab done before you walk out the door, but you'll have 2 weeks to work on the project for homework. This is the Java template. All right, come back to lab 2. So to do next week, before class starts, 10 points for the lab. Submit the URL to your main.java file. All right, write a program that ensures we have enough pizza to feed our friends at the party. Okay? So, a couple things we need to know. How many friends do you have? If it's only one, pretend I'm your friend. Right? You got at least me. All right? I'll come to your party as long as there's pizza. So, sure. So we have to ask them for friends, right? Ask the user how many friends they have, or how many friends are coming to the party. It's probably better how many friends are coming to the party. Okay? And then you probably know your friends pretty well. How many slices of pizza they each eat. We're going to guess here. It doesn't have to be accurate here. So we'll ask the user how many slices of pizza their friends eat on average. So if each friend eats 4 slices of pizza, sure, we can do some quick arithmetic here. Right? We can figure out how much we're going to need here. Right? Not too big of a deal. Okay? So we'll ask him that, and then we'll ask the user how many slices of pizza are in each pizza. Right? Like a large has 8, smalls have 6, or 6, 8, and 10. I forget how they cut it. Sure, it could be a different number. If you get like the Jets deep dish, you get 12 or something like that, right? I don't know. They come with different numbers, right? You look at me like I'm crazy. They come with different numbers of slices, right? Okay, thank you. Like I was getting some funny looks here.
Thinner slices, the larger they get. Ready to be
Thinner slices.
You got it.
So
Thinner and more slices, the larger. No.
No, a 10-inch pizza has like 10 slices.
a 10-inch pizza? No, 10-inch pizza is small. That's only, this is 10 inches here to here. Like larges are like 16, right? All right, it's all right. We can do pizza math later. So we'll ask them how many friends are coming to the party, how many slices they each eat, and how many slices are in each pizza, and then we'll ask the user how many pizzas they're buying, how many pizzas they are buying, right? Then we need to calculate and see if they're going to buy enough pizza or not. So we can tell them, yes, you're good, or no, you need to buy more. We don't even need to calculate the right number. We'll just tell them yes or no. Okay. So then we will calculate the estimated number of pizzas required and compare with how many pizzas they are buying. Tell them if they will have enough or if they need to buy more. So this is just one if else here, right? Either you have enough or you don't. Just a quick practice. Okay, but again, we're doing some input here. We're practicing input. It's using integers, right? Maybe doubles, right? If you say your friends eat 3.5 slices each, sure. If you want to do doubles. It's fine. Be careful if you're doing doubles or with integers and division, right? I think this is all simple arithmetic, just multiplication. I don't think we're doing any division here, right? Because friends times number of slices is how many slices I need. Number of slices per pizza times number of pizzas is how many slices I have. Do I have enough slices? More than enough of what I need. Right? That's a quick comparison here. Okay, that's our lab practice. So ideally, this one's a little quicker here. We went through a lot tonight, and we still have to get to the project. Does that sound okay? All right, so I've got that one. Let me talk about the project. Okay, then we will have lab work time. Or if you want to start it now, you're welcome to ignore me, come back to the video later, or just read what I type. That's okay too. So let me set up the project one here. Zero. There it goes. All right, so project 0, we've got 2 weeks to work on. But at the start of class, I'm going over a solution. So it's got to be in and done by 6 p.m. Please don't leave issues until 5:30. I got a bunch of emails from people. I'm assuming they're in the online section, emailing me at like 5:30 saying they're having trouble with the lab. I'm assuming that'll happen with the project. So I only have so much time on Tuesday. Okay, try and ask me questions earlier. So this is 10 points here. Now, again, the points matter in the category, not overall. So just because this is a 10-point project doesn't mean it's worth the same as the 10-point labs, right? Because the projects category is worth way more than the labs category, right? It's a weighted system here. It just makes the arithmetic easier because I don't have to turn everything into points. And that hurts my head. You submit the URL to your Java file. So with the projects, I'm going to add a rubric here that says, if it does this, you get points. If it does this, you get points. If it does this, you get points. So I'm going to ask you to use the rubric to score yourself. This is my last ditch attempt to make people look at the rubric so they're not confused when I score them. It happens. I know you folks are all paying attention. I love it. That's great. But some people are like, why did I score 5 out of 10? I'm like, there's a rubric right here. I said, you did this, you did this, you did this. You didn't do this, this, and this. And they're like, oh, I didn't know that. And I get really sad. So the main Java file and a self-assessment using the rubric. Now, the downside is the rubric looks like you can click on it. I'll show you in a minute. You can't click on it. I can click on it when I score you. You can't do it because D2L is dumb. I haven't figured out how to make that work yet. There's like a separate thing that does it, and it's really annoying because then it's separate, and that confuses me. So you're just going to like either copy paste or say, hey, for number 1, I got 2 points. Number 2, I got 2 points. Number 3, I got 2 points. Number 4, I got 2 points. Sure. Right. So it just any way you want to tell me you got the points is great, but I want you to look at the rubric and say I scored it. If you just couldn't finish it and that's okay. It's up to you. You can say, hey, I got points for this, this, and this. I didn't get points for this and this. I got 6 out of 10. I'll be sad because you didn't tell me you were having trouble, and like I probably could have helped you with it. But you know, that's okay. That's up to you. A C or better is passing. Technically, a D is, but like in your major, you need a C or better GPA. So like, don't bank on a D. Like at least C or better is passing. That's all you want. That's fine. That'll get you through. It'll get you transfer credit. It's okay. There's nothing wrong with C's. You know, not everyone has to get an A. So you know, if you just get 6 out of 10 or 7 out of 10, that's fine. It's totally up to you. Was that a question? I'm sorry.
Are you dropping any lower grade?
Of the projects, no. Of the labs, I'll drop a lab and I'll drop a quiz. So, but the projects, because we have 2 weeks for all of them, and there's only 4 of them, if I drop one, it's like a huge hit in the labs or in the projects. I can't talk. Yeah. Okay. All right. So we're going to write a program that helps your contractor friend build a deck. Okay. So to build a deck, you need to know a bunch of things and buy a bunch of parts and figure out how much things cost so we can give a proper estimate to our customers here. Contractors are actually really good at math because they have to do like napkin math all the time for everything that they're doing here. But computers make things easier. So I'm not saying that I'm not, you know, bless the people who do, you know, skilled trades. I can't do any of that stuff. I'm terrible with my hands. So I love that there are people who are good at this, but we're going to write a program to help them, right? So we need to get a bunch of information here. So we need to get the length and width of the deck, right? So ask them, what's the length, what's the width, right? How they assume it's a rectangle. We're not going to do anything fancy with like cool like hexagon shapes or angled stairs and all that stuff. Is that's too much. Just a nice little rectangle here for a deck, okay? So length and width, okay? And then we're going to ask them for the width of the board they are going to buy. I'm sorry, the length and width of the board they're going to buy. Okay, so depending on what material you use for your deck, if you buy boards that are a foot wide, right, and I have a 10-foot wide deck, right, I can do 10 boards across, essentially. If you buy an 8-inch board, right, I'm going to need more than 10 of those 8-inch boards to go 10 feet, right? There's some arithmetic here, okay? So we need to be specific here. I don't care what unit you ask for. If you ask them to enter everything in feet and say, hey, 0.75 feet, sure. If you ask them to enter it in inches and everything is 1 inch or 2 inch or 12 inches, sure. Completely up to you. It doesn't matter what unit you want to use. You just need to be consistent and make sure you're telling them what unit to use here. Okay? So length and width here, right? We line up a bunch of boards and figure out how many across we need. Then we also have the length here, right? If my deck is 12 feet long and I buy 8-foot long boards, I need an 8-foot piece and I need 4 more feet to go the 12 feet. And I need an 8-foot piece and I need 4 more feet to go the 12 feet. I need an 8-foot piece and 4 more feet. I don't care what length board you buy. You go to Menards, you go to Home Depot, you go to Lowe's, you see this board's on sale. It's a 10-foot board, it's on sale versus the 8-foot board. Let's go buy the 10-foot board. Our program needs to handle that arithmetic, right? If I want an 8x8 deck and I buy a 12-foot long board, I can cut that 12-foot long board into an 8-foot section and have 4 feet left over. Take another board that's 12 feet, cut it into a 4-foot section, take the 8 feet that's left over, right? That makes sense? So there's a little bit of arithmetic happening here. Not a lot, but some basic arithmetic we need to do to make sure that we have the right width and the right length. So solve one of those first, length or width, then you solve the other one, right? You're looking at me funny. We okay? Okay. All right, tell me if we're not. Why does it not like my grammar? Periods? I need periods. Thank you. It's still yelling at me. That's fine. Okay, so we need to calculate the number of boards required for the deck. Okay, and then we need to ask them for prices of their materials. Okay, so ask them for the price per board. Ask them for what else we need? whether can't spell or not the customer gets a discount. If they get a discount, ask for the % discount. So you can give a discount to someone if you want. You don't have to. If you want to, we'll say, okay, what kind of discount are you giving them? Are you giving 10% off, 15% off, 20% off, 30% off, right? We'll do some arithmetic based on our cost here then, right, to tell them how much we're going to charge them. Okay, so ask for the price per board, that's right, and then calculate total cost of boards. And then we need to ask for a time estimate and the dollar per hour they charge. So getting some information, right? So how much does the board cost? Figure out what the total cost of our boards. This is just material cost. And then we'll ask them how much you charge per hour and how many hours do you think it's going to take? Or if you want to count minutes and how much do you charge per minute, go for it. Like whatever unit you want is fine. Hours probably makes the most sense, but again, use whatever unit you want here. So if we give them a discount, great. We'll give them a discount offer rate. Hey, you're a family friend. I'll give you 20% off my usual rate here. Okay. So the discount only applies to the time cost, not the board cost. Right? We're not giving them a discount off of what Lowe's or Home Depot charges me. We're giving them a discount off of what our hourly rate is. Okay. And then we'll calculate the total cost of the project with materials and labor. Okay. So remember, if we're dealing with string input, if we're saying, hey, do you want to do this, yes or no? We have to use that string equals comparison stuff, right? Okay. Oh, sorry. So the cost per board here. So our friendly home improvement store. I don't know if I can actually use the right. I can say the words. I can probably type out the words, but sure. Offers a bulk discount if we are buying more than $1,000 in boards. We get 10% off. We are buying more than 2,000 in boards. We get 15% off. So some discounts that we get based on how much we're paying for the material from the store. So these ones need to be calculated here. So if the board cost is 1,000 or more, but less than, right, whichever order you want to do these in here, make sure we're doing it the right way here. We get a discount off of our price at Lowe's or Home Depot, the home improvement store. Let's say, hey, you're spending enough money here, we'll give you a discount. It's probably a coupon, right? Call it a coupon. Right? Especially if you use your Home Depot card or Lowe's card, they love giving you percentages off because then they make money charging you interest, which is like not how companies are supposed to make money. They're not a bank, but that's a whole other story. So sure. Okay, and then we can give the customer a discount if we want. This is totally up to us. Discounts just our time, total cost of the project, materials and labor, and output the total cost. Okay, this makes sense? I hope it makes sense. It's a bunch of steps. We're doing a bunch of things here. A couple different conditions we have to check for, right? Whether or not we're getting discounts, what our discount is at the Home Depot store. A couple different things happening. So get it down in English first. This is close-ish, not all the way there, right? You know, you need more detail than this before you start writing Java code. You'll be much happier if you get more detail in. Okay, and then for our rubric here, for project 0, so it either is complete or it's missing. So ask for deck length and width. 2 points just for asking and storing. So like getting those values here. Get the length and width. Get the board length and width. Calculate number of boards required. Okay. Apply discount to so this is get cost of board, and apply discount.
None of this is dead.
No, I can type in any numbers I want. I can build a 1x1 deck. Sure, if I'm buying an 8-foot board, I still have to buy one 8-foot board, right? I can't buy half a board from Home Depot. I mean, I guess you can, but they're going to charge you full price anyway. Right? You can go use their saw if you want, which is actually really fun to play with those big saws. But they're still charging you full price for the board, whether or not you take the whole thing with you or not. So, right, if you've got extra board, you still bought that board. You can't buy half a board, right? So the cost per board, apply the discount, ask for customer time or labor discount, and apply. And then output total cost at the end. Okay, I think that's everything here. So 2 points each, right, for each step of the way. Ideally, you get it all done, but totally up to you, right? If you want to just hard code length and width and not ask the user for it, you don't get the 2 points. But sure, everything else will run and just say, oh, I'm always building a 10x10 deck. Go for it. You can get 8 out of 10 if it's always a 10x10 deck. That's okay. It's up to you.
How much time is it?
2 weeks.
Oh.
Yep. This overall score thing I can't get rid of, sorry. So I just rename it. Just ignore it. Oh, is there rubrics visible? No, okay. I was hoping you could like use it. Lame. All right, so that's the first bigger project. A little more involved, more steps, more stuff happening here. Again, if you're stuck on it, I'll get you pointed in the right direction, but I'm not going to like sit down and write the code with you like we do for labs. Okay? So when you click on it, when you go to, hang on, I got to pull on view as a student. Let me see this here. I think I can do that. So when you click on project 0, it's down at the bottom here. So it looks like you can click on it, but it doesn't actually do anything here, right? So like you see it here, but you can just say, hey, for number 1, I got 2 points. Number 2, I get 2 points, or like copy paste these.
When it comes to the rubric, can I just put it in a comment?
Yeah, or just, I mean, ideally it's in the same box here. Put the URL in and your rubric score.
Oh, when I score myself.
Yeah, ideally it's here. If you want to put it in your code, I can probably find it too. But usually this box here, URL and rubric score.
Stanley rubric.
Rubric. Okay. All right. So I got 9 o'clock here. We got about an hour till they kick us out for lab.
I know what time we closed.
Yeah, sure. We're close.
You need the box of juice.
Maybe we can offer him some coffee. So, yep. All right. So I'll end the stream.
Okay.
And we'll go from there. Hey, thanks for hanging out, Cyrus.